I'm Yen Hamida. It is an honor for me to serve you as the master of ceremony for this event. Ladies and gentlemen, the International Conference on Information and Communication Technology ICOICT 2020
Hello.
is an annual event. We have been conducting this event since 2013. In 2013, 14, 16, and 18, the ICOICT was conducted in Bandung, Indonesia. While in 2015, we conducted the conference in Nusa Dua Bali, Indonesia. As we have been working together with Multimedia University Malaysia since 2017, in 2017 and 2019, we are so glad that we had a chance to conduct this event in Malaysia. And this year, under the theme of leveraging ICT for disaster resilience and sustainable development, the 8th ICOICT 2020 is organized by Telkom University Indonesia, Multimedia University Malaysia, and Universitas Gadjah Mada Indonesia in association with the IEEE Indonesia section and the IEEE Signal Processing Society chapter. The 8th ICOICT 2020 was firstly planned to be conducted in Yogyakarta, the home of the intellectual academicians and the city that is known as the city of the students, in which you can find many educational institutions there. Unfortunately, due to the coronavirus, the event is conducted in a virtual conference. However, no need to worry. The committee have been working so hard to make sure that each and every one of you can have the best experience during the event. So ladies and gentlemen, to welcome you to this international conference, we would like to show you the video on the journey of ICOICT. So please enjoy the video.
Good morning, everyone. Pak Idam, I would like to invite. Are you ready? Oh, okay. Good morning, everyone. Today is the second day of ICOICT 2020, and the first is tutorial speaker number 3 for Mr. Idam Ananta Timur, STMcom, the entitled Toward Autonomous Robot for Disaster Mitigation Support using Deep Reinforcement Learning. And before our tutorial speaker number 3 start, I would like to invite Mr. Idam to coming here in online. Go to webinar today. Pak Idam, could you coming here and show your web camera?
Morning, Mr. Sandal. Nice to meet you.
Good morning, Pak Idam. How are you today? Could you hear me?
Yes, of course, loud and clear.
Okay, thank you. And before we start your video tutorial, I do like to read your brief curriculum vitae. The complete name is Idam Ananta Timur, STMcom, from Department of Computer Science and Electronics, Universitas Gajah Mada. And his research interest in intelligent environment and the other activities. He active as a member of computer system and network research, and also working on the idea how autonomous robots collaboratively interact within an intelligent environment. This is your short curriculum vitae, but this is just jokes maybe. What is the related with the Pramudia Anantatur? I'm sorry, this is just joking to enjoy today. No, that is actually. I just remember the novel author. The name is Pramudia Anantatur, and your name is Timur Tur, and Timur is almost similar. Sorry,
Yeah,
just kidding.
plus similarity level is quite high.
Okay. Yeah. And also you are author and also writer, the good writer. Okay, sorry, Pak Idam. This is just kidding in the morning. And before we start, if you want to introduce of yourself or anything else, comment maybe, please, before your video is play.
Okay, thank you.
Introduce of yourself maybe or anything else.
Yeah, thank you,
Please.
Mr. Iskandar. Well, I guess my name is already there, and I think not many of me that what to tell about. But the thing that I would like to explain here is that maybe the title would be like exactly the title. Well, my original video is about the mitigation, disaster mitigation, but it took too long, and then I just got in the small section of the autonomous robot with end-to-end learning. So actually I cut a little bit of the topics here. So please accept my apologies before.
Yes. All right. Oh yeah, thank you. And maybe now is your time, so please play his video of today's tutorial number 3. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, dear everyone, welcome to our tutorial session. My name is Idam Ananta. I'm a lecturer and researcher at Department of Computer Science and Electronics, Universitas Gajah Mada. We're supposed to meet here in our beloved city. However, with the COVID-19 pandemic situation like this, I think the online session will be the best we can do here. I would like to take this opportunity to talk to you about the story of end-to-end deep learning approach for autonomous robot. The purpose of this tutorial is to share with you our early experience, hands-on about the approach, to see how it works and how good it is in a glance. After this tutorial, I hope you get a better concept, better insight about this approach and a good place to start. So here's the overview. I'll start with the end-to-end deep learning concept, what it is, what is the benefit, what is the consequence, and then I'll try to demonstrate how an end-to-end deep learning works. Start with how to get the data, how to pre-process it, how to build a model based on it, and how to test the model to see how it works. And at the end, I'm gonna share with you some of our early thoughts, and hopefully we're going to have a good discussion afterward. In the case of autonomous robot, for example, usually we have a set of sensors like camera, lidars, gyroscope, accelerometer, etc., and actuators like set of motors. To make this robot achieve some level of autonomy, we usually develop an object detection mechanism. Usually it works with those sensors. Using camera, for example, we might develop some clever image processing so that the robot might be able to detect, recognize, or even track moving objects. Next, we still need to devise a method to assess the situation of the robot itself. It needs to know what it is it in danger, or maybe somehow causing danger to others. Or maybe, at some case, it needs to predict what happened next. When it knows its situation, it also needs to plan forward for what it has to do. Does it has to move forward, doing some evasive maneuvers, pick something or else? And depending on its sets of actuators, it needs to map the planning into the control when it has to deal with set of actuators that the robot has. So it's quite complicated, and sometimes, or maybe more precise, most of the time, it is a troublesome process. So, what an end-to-end learning approach does in this scheme is reduce those handcrafted complexity into a mapping from one end, which are the set of sensors, to another end, which are the set of actuators, using a single neural network representation. Yes, I know, especially for you that not familiar with this method, you might wonder, seriously? Well, it does seem like an oversimplification. And to believe such system is working might be even harder for those who spent many years of their career engineering individual steps of the pipeline, such as object detection, collision avoidance, path planning, etc. They might already wrote multiple papers, developing tools and or libraries, and has significant recognition or income or both from those works. And these methods kind of like saying, okay, we probably don't need those anymore. Nevertheless, one problem that gets in the way for any end-to-end learners is the fact that it needs a lot of data, tons of them. It might be easier to develop end-to-end learning in translation system, for example, because there are a lot of multi-language datasets out there available. In the case of autonomous robot, it doesn't seem the case because, going out there many times with the robot collecting tons of data will be very expensive and time consuming. So is it the end-to-end learning unlikely for autonomous robot? Well, not really. What if they are able to generate their own data? What if they are able to develop a simulator and let it collect data for you? Recent development in computer technology is not only about computing power, but among other things, is the development of virtual worlds. There are numerous photorealistic virtual worlds around us, and it doesn't take too long for a group of researchers to develop a simulation engine for autonomous project to generate the data and the environment needed. and these are some of them. Okay, so what I want to share with you today is our early experience working with the AirSim. So AirSim is another good simulator to develop, among other things, the end-to-end deep learning. It is developed by Microsoft. It is open source and freely available for everyone. It's built on Unreal Engine, and it also has an experimental version on Unity. You can get it from the GitHub here. So if you click their GitHub site, then I think you have all you need to start with the AirSim simulators. And they also give you some kind of introduction to the autonomous driving. They call it the autonomous driving cookbook. It is very good place to start, so we highly recommend this cookbook. And actually this tutorial is largely based on this autonomous driving cookbook, so we would like to thank Mitchell Sprain and also Aditya Sharma as the authors, because they are they have inspired us to try this platform and get better understanding about the concept of end-to-end deep learning. And this is the plan that we're gonna do today. So the first, we like to generate the data set. And second, we will pre-process the data and then we train the pre-processed data. And the last thing is we try to test the model that generated from the training. So it's like usual supervised learning pipeline. And this is what you need. We highly recommend you to create your own environment here. You can use the Anaconda. We're using Python 3.6 and any other library here that you need to install before you start. And well, honestly, I think you're gonna face some kind of compatibility problem because the library is keep updating. But I believe you're gonna be okay after visiting some of Stack Overflow pages. So, so I think you don't have to worry about that. And you can also download the simulator package. So basically AirSim has the environment and also the simulator package. If you want to work with the autonomous driving cookbook, you can use the simulator package. But the one that they keep updating is the other one, the environments. You can also download the data set. If you don't want to generate data by yourself, if you don't want to create or driving manually to create the data set, then you can just download the available data set from the AirSim just to look at how it works, how to train the data, and how the resulting model can perform. So it's optional actually. And well, the last thing is that decent GPU and also a bigger RAM will help you a lot. Okay, let's look at the neighborhood environment. So as you can see here, it has wide roads and yeah, some intersection. It is also a static environment. There are other cars here, but they are not moving, so you don't have to worry about them. Of course, at some point, they might be considered as obstacles on the side of the roads, but it's okay. We'll see how the end-to-end learning deal with them. We can use the keyboard like I do here to drive the car. Use the arrow to move the car forward. Brakes, turn left, turn right. So pretty much, I think it's wait a minute. Okay, it's still running. Okay, so bottom line is you can use the keyboard to control your cars. However, one technical note that you need to consider is that you need a decent steering wheel or joystick to get better data. Previously, we used keyboard in our training, but after generating quite a lot of data, we realized that keyboard only has a discrete steering angle. So if you look at the up left of the screen, then you'll see that the steering is from -half to 1/2, -half to turn left and a half to turn right. So it's I think it's a discrete. But if we are using a joystick here, let's see if we can have a continuous steering angle. Okay, so if you look at the left side of the screen, then you will notice that the steering angle is also continuous. Well, it's quite difficult to control the car using a joystick if you're not used to. But yeah, I think the ideal device will be a steering wheel. So in this demonstration, we're gonna use this joystick, and we're gonna deal with the complexity. Okay, next you can toggle the depth camera by press 1, or the segmentation camera by press 2, and press the 3 for the RGB camera. This is an important feature because we will work with the image. So good news is we can easily record our image along the way just by clicking the record button, or simply press R on our on our keyboard. Okay, let's try to record some of our movement. I press R button in the keyboard now. Okay, recording started, and okay, let's do this. Okay, so yeah, it's a bit of difficult to write with this joystick, but yeah, we can still do this. Okay, hit, and let's stop the recording. We can find the recorded image these folders, documents, and RSIM, and you can pick the last one. So here is your image. So I think it's quite few images we have here. And the good news is that the RSIM also save our steering behavior. So like this. So it has like a timestamp, the location of the cars, the throttle attribute, steering, brake, gear, handbrake, RPM, speed, and image file. So it has quite a big data here. So that's how you record the image and the steering behavior. Before we continue, I need to emphasize that the fact what we're going to do is a very simple end-to-end learning. So the objective is simply to keep the car on the lane, on the road. And we're gonna see this as a problem of regression using a CNN with a set of images from front camera and the vehicle's last known state as input and the angle of steering wheel as an output. So first we need to take a look at how we drive around. The intuition is if we drive carefully, let's start from the beginning. If we drive carefully, then the car will follow. Hopefully, it somehow imitated our driving style. However, it's not enough. An end-to-end learning, as I mentioned earlier, doesn't do feature engineering. So the only source of its learning is that it's a teacher for manually driving like this. So we should provide all necessary information so that the car able to drive by itself. So it's a good idea to teach the car also to take a drastic measure like turn sharply. For that reason, we will do two different driving style. Let's say normal and swerve. So this is the normal style. And this is the swerve style. So you will create kind of oscillation like this. The objective is to teach the car how to turn sharply if needed. So that's how we're gonna do our data generation. So we're gonna do 6 normal style driving behavior and 3 swerve style driving behavior and save them into different folders. So that's it for the data generation. Okay, so here is the code for the pre-processing step. As usual, we need to look at where our raw data is, and of course, also organize them into normal driving style and swerve driving style as well. And next, we will take a look at some sample images that we have from our training. Or let's just run this file. Okay, so here is the image captured by the car's front camera, something like this. Actually, we only care about the road, the lane. So if possible, removing unneeded portion of the image will reduce our need of computing power. So we're gonna crop some region of interest into something like this. So it's smaller image, so hopefully it can help us to gain a faster learning speed. Next, we also need to take a look at the distribution of the steering angle and also distribution of the swerve and normal driving style. As you can see here, we have like 65% of normal driving style and about 35 to, yeah, I think 36% of swerve driving style here. Having tried the normal driving style 6 times, for example, and swerve driving style 4 times, maybe, doesn't always reflect the distribution, as it depends on how long we do each of these driving styles. And finally, let's take a look at how many data points that we have to get a better description. So this is the histogram of our normal driving style level distribution. So I think it's around 0 actually. And yeah, it's gonna be a problem for our neural network, since it will most likely recommends or predict 0 steering angle most of the time. So I think we should reduce this number so that the 0 is not predicted all over the time or most of the time. And if we look at the histogram of the swerve level distribution, it's something like this. And then okay, the code will read the data. Basically what it does is try to combine the image and the non-image data into one, and it creates kind of big H5 files for our data. So I think it reads, yeah, processing data. It took a while. Once you finish, then you will have at least 3 pre-processed data set in a H5 formats. I think that's it for the data pre-processing. Okay, if the data processing goes well, then you will have these 3 H5 files. It has a very big size. For example, for the training dataset, you have 3.5 gigabytes, and from the eval dataset, you have more or less 1 gigabyte, and half of them for the test dataset. So next step will be to train this dataset to develop our model. So let's read those data and define our dataset. It is too expensive to load the entire dataset into memory, but lucky for us, Keras has data generators. Basically, it's an iterator that will help us read data from this in chunks, so we don't have to put all of them at memory at once. So I think it's the best to do for our situation. And next, we're gonna apply some data transformation to create a richer data. What we're gonna do is try to flip around the y-axis. As the car in neighborhood environment are actually driving on flat environment, there should be no significant y differences. We can also see this flipping transformation as passing the same road from the opposite direction without having to do so. The flipping image the flipping image is, I think, is quite easy to do. However, we still have to flip the label as well. As this is a custom requirement, we need to extend the image data generator class here, and we're gonna implement our transformation of the labels manually. Another transformation that might help is to try different lighting scheme. As our car is expected to drive autonomously in different time of the day, if you look at the color feature in the previous video, you might notice that it provides a night simulation. We are not aware if AirSim provides the same capability. In fact, AirSim has ways to get different weather effects like raining or snowing or a different time at the day. However, in our demonstration, we take a different approach. We can randomly set the brightness of the image to simulate lighting dynamics. And we can do that without having to manually driving into different weather or different time of the day in the environment. If we set, for example, the brightness level of our training to 0.4, then the brightness of its image will be modified by up to 40%. To do so, we need to transform the image from RGB to HSV, and we're trying to modify the V scales up or down, and the result we're gonna transfer back to the RGB space. And then the next step will define our network architecture. So here is our network architecture. So we use a combination of standard convolutional and max pooling layer to process the image. And we're gonna inject the last state of the car as additional feature into the dense layer. And yeah, these parameters might not be the best, but we'll see how it works. Okay, finally, let's see how good our end-to-end deep learning is. Please keep in mind that the purpose of our learning model here is simply to keep the car on the road, simply to keep the car on the lane, so as long as possible. Let's start with the imports module here. As you can see, we only need the Keras models to load our trained models, and the other component, the other modules you need here is just like a standard modules, and you need to define this as well to facilitate our connection to the AirSim. You need the AirSim client as well, so make sure that it already in your folders. And then this is the path to the models, and you can put it here, and this is the line of codes to load the models. Next, we're gonna connect to the AirSim simulators. Before you do this, make sure that you open the environment first. So let's open our neighborhood environment. Okay, wait a minute. Okay, here you are, the environment of neighborhoods. And then this is the line of codes to connect to the environment. Next, we initialize some of the car parameters. We also provide with some buffers to start our models prediction. And then we will need the cars in our IRSIM to get the image. So this is how you get the image from the RGB camera from the IRSIM. And then yeah, this is where you start the control. So first it will get the image and the state, and it tries to get the output of the models, and it will fetch the steering angle into the car's control. Okay, so that's it. So okay, let's see how it runs. Let's run this Python file. Oh, wait a minute, I need to change this into my virtual environment. Yeah, Skynet, it's that Skynet. Yeah, we have, oh wow, it's running. See, this is the model tracking, is not me. So yeah, that's our model. Let's see if it can make the first intersection. Can it pass it safely? Can it turn? Oh wow. Okay. Still running, still running, still running. You know what? I think it's pretty good for a very little dataset here. It passed the road with the shadows, and let's see if it can survive the next intersection. Okay, a little bit bump here, and okay, still going, still going. I know you might wondering why the car is doing something like that. Maybe some of you have some kind of hypothetical reason why the car's behavior is like this. Maybe we put too much self-driving style into our model, so maybe this is the output of the model. So let the models drive our car a bit more, and let's see how far it can go. Still going. It's pretty much. It's going, it's going, it's going. And let's see if it survived the next intersection. Okay, another bumpy turn, but still survive. Another turn. Can it make it? Okay. Okay, what's out of the car? What's out of the car? Wow. Okay, it can handle that quite good. Still going. What's the car? Okay, it hits the first car. So, what do you think? Are you ready to let the end-to-end model take over your car? No? Yeah, me neither. My daughter said no is a big no. And I think she got the point. Even Andrew from Coursera didn't recommend the end-to-end deep learning strategy for autonomous driving. And one might argue that he or she can make a better autonomous robot using more traditional approach, like using an object detection system or collision avoidance system, etc. But to be fair, Andrew's video was a few years ago, and he didn't mention about the possibility of simulators that might help us. And to make another fair point, we only took a very little data set here. We took 6 normal driving styles around the neighborhood and 3 swerve driving styles as well. And those are all the data we have. And this car, which learned from those limited data set, has managed to survive quite a long time. Well, this is not always the case, of course, but I believe this achievement is quite promising. In the end-to-end learning is good as it let the data speak. If it speaks and good enough, it will hopefully capture all the features needed in the right distribution, and it leads to less hand designing of component needed, though it will potentially exclude many useful hand design components such as object detection, path planning, etc. End-to-end learning obviously needs a large amount of data. Simulator will help, but it remains to be seen on how good it is in the real world. However, with techniques such as behavior cloning, simulation results can be fine-tuned using lesser amount of real-world data and used on actual cars. One other problem for this approach is that we can't always explain the car's behavior. It massively relies on the teacher to perform a comprehensive driving style. The other thing we can do afterward is only tune the parameters to hopefully get the best model. There's another techniques like deep reinforcement learning that might help you customize the driving style along the way using reward and punishment mechanism. Interestingly, our model in the end-to-end learning can speed up the deep reinforcement learning training using transfer learning. You can also try it on IRSIM as well, since it's also provide the tutorial. So there you are, our experience, and I just want to say to you who already mastered feature engineering and other skills on the more traditional pipeline, not to worry. I believe this is not the end, and the end is not even near. Even in the future, I believe there are so many useful things that we can do with this amazing skill set. And if you are end-to-end early adopter, I know what the temptation is. You don't have to master those individual skills in the pipeline and still hoping for a decent result. What I show you today might be a good place to start. It's not bad, it's promising. The good thing about this is that there are many open questions in this area that your brilliant mind can help. Thank you for watching. That's all from me. Looking forward to a good discussion. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Idam, for your slide and explanation. This is very interesting to show as a new paradigm in machine learning. So I would like to check any question, comment, or anything else. And first, I have one question in the question box, and maybe you can check in your application go to webinar in the question box. The first is, what is the difference between deep reinforcement learning and reinforcement learning? Could you explain why one by one? Thank you.
Okay. Well, I think it's a good question. So actually, this video is not about the reinforcement learning, but the introduction why we might need the reinforcement learning. So to make it simple, I try to explain in this way. One of the problems with the method that I showed you today is that I said earlier, we can't really explain what happens. As you might notice, our car is like doing some kind of oscillation. Yes, it may be we put the source data style too much. But imagine this the situation like this. Okay, I think the car is safe mostly, and then we would like to change the behavior a little bit. For example, you are in Indonesia, and in Indonesia, we drive on the left lane, right? So the question is how we can modify this kind of models to let the cars drive mostly on the left for its safety. The only way in the end-to-end learning or deep learning at this point is to create another driving style, or to teach manually. You have to demonstrate how to drive the car most of the time on the left lane. So that's what we can do in the end-to-end learning. And this is kind of well, for some is quite troublesome, because every time you want to change the behavior of the model, you need to train another data. And this is where the reinforcement learning comes from. We can modify the models using the deep reinforcement learning technique. And how we do that is by creating some rewards and mechanism training. So in reinforcement learning, as the question is about the reinforcement learning, reinforcement learning is learning from the behavior. So it tries to learn, it starts with the random action, and then along the way, we create a reward and punishment mechanism to train the agent to get a better behavior. So in the case of our driving, for example, if we want the car on the left lane, then we can have some kind of mechanism to get the reward, so that the car, when it's on the left lane, will get a bigger reward. Afterward, after so many iterations, the car will learn that if it drive on the left lane, then it got the bigger reward again and again and again, and the accumulative reward it learns is the result will be the agent that most likely will drive on the left lane. So the good things about the reinforcement learning is that you don't need to create another data set to change the behavior. You only need to change the reward and punishment mechanism so that it can drive autonomously, or maybe I can say it can learn autonomously as well, as long as you give it correct or proper reward and punishment mechanism. So that's why this video is a way for us to try to learn more about how we do what we call deep reinforcement learning. Okay, so next, the difference between the reinforcement learning and the deep reinforcement learning. Reinforcement learning was quite old, I think. Yeah, if you look at the book of Sutton, our holy book of the reinforcement learning is quite a few years ago, and it has like its momentum in the last few years, because it introduced the use of deep learning combined with the reinforcement learning. And I think that's the ultimate difference between the classic reinforcement learning, when it only tries to learn about the state, the action, and the reward that the agent get from some much iteration. And when it tries to use the deep learning to predict what is the next value of the state. So, for example, if we use the classic reinforcement learning, we can only in the classical reinforcement learning, in the Q learning, for example, we rely on what we call the Q tables. What the Q table is, it stores the combination of state and action, and it tries to get the best value to decide what is the next action is for a particular state. However, this table has some limitation, and one of them is the dimension. If you work with the image, for example, then you kind of have like a explosion in the dimension, and it needs you to think about another way for doing the reinforcement learning. Deep reinforcement learning comes here and tries to have a way to predict the next state using deep learning, using the deep, for example, the convolutional neural network that we use here also, and it has a better result. I mean, I think the main papers, the legend of our for every reinforcement learning fans is that it kind of imitate, or it kind of have some more skill than human in particular games, and it comes when it tries to combine the deep learning and reinforcement learning, and it turns out to be a big win. Well, of course, in the computer games as well. So I think that's what I can explain a bit about the difference between reinforcement learning and deep reinforcement learning, and why this video is it's a good introduction to go to that way. So,
all right, thank you, Pak Idam. And the others question, oh sorry, I wrote in the answer box. And the other question, maybe I would like to ask you. I think the inherent issue of reinforcement learning is mainly the factorial spatial complexity, right? And this when you really wish to utilize something similarity to multi-front, expansive vectorial dimension, something like that. So to make the idea of running lazy evaluation or what's not, you are going to run into the issue of having to assert the memory allocation of the kernel. What do you think to this solve of this problem?
yes,
regarding to the memory allocation of the kernel, yeah.
Yeah. Well, actually, we experience it. So after we've done with the end-to-end learning in our videos, and we continue our research in how to use the next step, that is the reinforcement learning, or deep reinforcement learning. And well, we have a computer with quite good GPU and quite big RAM. Well, for us, 16 gigabyte is quite big. But sometimes in our training, it looks like for reinforcement learning, it's not unusual to have like a 5 days training, and sometimes at the second days it stopped because we don't have enough memory. There are some approach that we can do here. For example, we can reduce the bit size. So in deep reinforcement learning, we usually just kind of replay memory. So basically, it tries to collect some of sequence of action and states, and then use this as an input for our neural networks. However, if you take the replay memory as big, then you obviously will need a bigger computing power and bigger RAMs. The trick was like try to have like a smaller replay memory, but it depends in the case. And in our case, well, it sometimes works and sometimes well, it's not working. So that's one of our trick to
I think so.
with this memory requirement. We can also, but we haven't.
And sometimes, you know, that's
we can also the cloud.
hello, could you hear me?
Because they give us like an unlimited resources, but yeah, it's also have some expensive problems. So that's another way to do that.
Yes. And you know, sometimes that's reinforcement learning must or learning model of environment, and this need to know where action lead, where action, or sometime for making decision, maybe something like that. How your idea to use a more deeper knowledge this reinforcement learning algorithm? Need to know where action lead in order to evaluate action, maybe something like that, or making decision.
Yes.
Any idea maybe to think this problem?
Okay, let's take a look at this
Hello?
autonomous driving case again. We need to define some of basic reinforcement learning concept. For example, we need to define what the state is. So we can define the state as we have the state representation, for example, as the image in front of our cars, and the the speed of our cars and else. So what the reinforcement learning test is, it pairs between state and action. So when it comes to state A, for example, and it tries to do the action 1, for example, it tries to calculate the value by calculating the reward. If it has a big reward, then the value of this pair is greater. So that's how the reinforcement learning play for this type of learning. So it pairs the state and action, state and action. Sometimes it takes the same state for a different action and look at which has the greater reward, for example. And after doing some iteration, it has like a proper table, for example, to know what is the pair of state and action that has the best reward. And then that's how it decides what is the best action to do.
Yeah.
So that's kind of the description of the how the reinforcement learning.
Okay, we move to the next question. Sir, have you ever heard of research linking robot control using EEG signals and deep environment learning? EEG for linking robot control, maybe something like that, using EEG. You can see in the question box.
Yeah, to control robots using the EEG, it has like a two kind of problem. The first problem is how to translate what happens in our brain, and then the second, it tries to map from the input of the from the output from the brain signal into what kind of control that it wants to do. I don't know if there are deep reinforcement learning to do that, because actually from my perspective, I would recommend a more deep learning only approach for this case, because for example, I took the data. I think, for example, I will flip this remote and using some kind of input, and the expected output will be I move this remote. So when we have like a few data set, then the deep learning might work better. But the question, if we want to use like reinforcement learning in this equation, in this case, is that you need to create a kind of reward or mechanism for the agent to learn which has a better action. So if the purpose is to translate, to map what we think and what the action is, then I don't think that the reinforcement learning, as far as I know, is suitable for that. But for example, in the OpenAI, it's the prominent platform for every reinforcement learning fans. It has the demonstration of how it learns to solve the cubic box, you know, the Rubik's box. So it's using a robot, so it has like a reward and punishment mechanism, and it tries to like have a single hand to solve the Rubik's with only a deep reinforcement learning, and it does it quite good. Even if we try to disturb this process, it's still, well, some of the cases it still successfully finish the job. So the reinforcement area is when you try to like ask the agent to do some particular stuff. But if you want something that imitates some things, for example, I will recommend the deep learning approach. So as far as I know, we haven't seen any combination using electro AG and deep reinforcement learning, but I think it depends on the case.
Yeah, depend to the case.
Yes.
And we check again the questions. The next question. I'm sorry, I'm late. What your reinforcement learning algorithm is used, policy-based or value-based? Would you kindly elaborate the algorithm use-based and how the agent get optimal policy?
Okay, so this is another question about reinforcement learning.
In question.
Okay,
I think so.
Because that's also actually I'm more interested in the reinforcement learning than the deep learning. Well, the combination is also my my interest. So in this approach, we're not using any reinforcement learning step. So it's all deep learning. You create the data, you pre-process the data, you train the data, you test the data, and that's all. So we don't use the reinforcement learning at this moment. But actually, we can use the model from this experiment to help the training of reinforcement learning, deep reinforcement learning. And I think it's a kind of great things to see how the models that built from the deep learning can actually help the reinforcement learning. And if you ask what kind of reinforcement algorithm that used for the for our trial in reinforcement learning in this autonomous driving, we use the policy based, yeah, not the value based. simply because that's what's available at that moment. And well, I have to be honest to say that the result, well, we haven't got any best parameters to do this well. So the reinforcement learning experience that we try first in our labs, but we try to do a deep Q network for a quad rotor to follow the power line. So it basically tries to look at the image of the power line. We will give the quad rotor a reward if it stays close to the power line, and we will give it a penalty if it crashes, it hit, or it goes away. And the Q network for in this experiment is I think it's working well. This is we're using the value based algorithm. We also try to develop the collision avoidance system also with deep Q network, and it also works. We create our own environment using Unreal Engine, and we use the deep Q network as well, using the value as well. But the result is quite good. Well, but it's a simple environment that we built. But when it comes to follow the model that we train with the end-to-end learning, and we try to speed up this into our reinforcement learning. Well, we have like a lot of problems actually, and we haven't got any solution yet. But the things that come to our mind is that we haven't got the best reward and punishment mechanism, so that the result is not quite good. Oh, I forgot to mention the case. So in our deep reinforcement learning experiment, we try to have some kind of navigation. So the idea is if the car turns right at some location, then it will get a better reward. But after trying, it's I think we successfully have like a successful reinforcement learning training, and we can see that the reward is increasing, and we got like the convergence. However, for 1 or 2 target point is okay, but when we try to have like a few target point, then we still have a problem there. And that one we using the policy method. That's a bit of our story in our labs.
Yeah, thank you for your detail.
Yeah.
Yeah. And next question, because our time is until 10 a.m., almost 40 minutes again. And the next question from Lukman Abdurrahman: how do you relate deep or machine learning to neural networks?
Okay.
In question box from Lukman
Yeah.
Abdurrahman, the asker.
I think there are many books that will have a better answer than me, but for my experience, yeah. So the deep learning actually it has like a more layer than the traditional neural network, and it has some kind of mechanism to even have like a intrinsic feature engineering. So it relies on convolutional layer, pooling layer, and other stuff in that we usually have in the deep learning. And providing we have big enough data, then the deep learning usually will have a better accuracy at the end. But for us that work with the robots, the problem with the deep reinforcement learning is that it's expensive. You need like a very powerful computing power, and one of our vision in our labs is that we have robots with limited computing power, but still can like do some simple machine learning stuff. And as well, of course, camera is one great sensor to have, but many of our robots only have like a distance sensor, infrared sensor, and the data is not as complicated as image. So it's just a number, for example. And actually, the simple neural network might work. And yeah, we want to try to do this using like a very limited resources, so that our like a smaller, cheaper robot can achieve some kind of good result as well. So that's how we look at the deep learning and
machine learning. And the next question from Miss Yunitasari, if the idea of end-to-end learning is to wrap a list of components into one black box algorithm, how to design the best architecture in order to cover this components role, especially in complex tasks like self-driving car, something like that maybe, or autonomous vehicle?
Well, that's the problem. That's the problem in the end-to-end learning, because, like I said earlier, we can't really explain what happens inside, and how to get the best architecture is you do some kind of trial and error. Let's just have some additional layer here. Let's just add another feature here, and hopefully for a better result. So my biggest complaint about the end-to-end learning is that we can't really explain what happens inside. Well, the temptation is good, you don't have to do some, object detection and many things in the pipeline. But at the end, maybe you're likely to have good models. But if you want to somehow to change the driving behavior or to change the goals of the driving style, then yeah, the obvious way is try do some another training, try another architecture, and yeah, that's the case. I don't know. Sometimes I think the end-to-end learning is quite like well, it really depends on the data that you can provide. If you have for our case, the driving style data that is comprehensive, it looks many turns, it has like a long or bigger, significantly bigger than our data set, then it might eventually to have like a better models. But if the question is what is the best, well, we don't know.
To decide. And okay, to the next question. In this demonstration, you create the simulation on the virtual environment for agent to learn. As for the real world environment, do we need to retrain the agent to learn new policy on this? Sorry, new policy. Oh, sorry. The question is Q. Oh, sorry, more. Once again, in this demonstration, you create the simulation on the virtual environment for agent to learn. As for real world environment, do we need to retrain the agent and new policy on this new environment?
Yeah,
To retrain the keywords in the new environment.
A good question, I think. What we know about why the simulators is interesting is because, well, if you want to do something using R, for example, and doing this end-to-end learning by yourself, then, like I said in the presentation as well, that it will be an expensive and time-consuming, not to mention the risks that it might hit and stuff. But the good thing is there is some methods to use our models that train using this end-to-end learning from the simulators and to use it outside. And it helps you to refine the models on the real worlds. So this is quite interesting. So even in the simulators, what I show you is the environment of neighborhood. The AirSim has a sample of models that train in the completely different environment. It's a mountain landscape. So we try to use this model into the our neighborhood environment, and it's still running. Well, not as good as our model, but it's running. I mean, oh wow, this is what we call the transfer learning from mountain landscape environment into neighborhood environment at still going. And the good things about that is that using this model, we might don't need to start from the scratch, start from zero. Especially if you use the deep reinforcement learning approach when you can modify the models. So the idea is let's try to start with the end-to-end learning with simulators, and then let's take it outside with behavior cloning. And when you drive your car, of course, you still have a steering drive here, and the end-to-end learning tries to drive your car. You can just follow the car, but when it tries to hit another car or another object, you take over the steer and you drive it to safety. And this is the mechanism into the reinforcement learning as well. So this action is evaluated into the next iteration. And using this transfer learning from the end-to-end learning into the deep reinforcement learning is quite interesting because you can save a lot of time for the beginning. And in this cookbook, the authors also said that if you try the deep reinforcement learning from scratch, you will need a few days to get good models. But if you use the transfer learning, you just need a few hours to get a good model. So I think that's quite a good idea. I mean, we don't use this as a final product, but we try to use this as a base for another model that we want to develop in the real world. So that's I think the idea.
Okay, nice answer. And also we found there's any question in the chat box from Firman. There are several artificial intelligence algorithms that can be used to program autonomous robot, like fuzzy logic, neural network, machine learning, and so on. What algorithm do you think that are the most effective to be implemented in autonomous robots like your video?
Yeah.
Which one?
Again, I'm quite
The effective algorithm.
to pick one, right? So it depends on the case. So if your robot has like high computing power, then well, I think the recommended method will be like the advanced, like deep reinforcement learning or even this deep learning. But if you already you only have like a very limited resources computing power, then I think you should look at the simple one, the simpler one. And I don't really believe that as we use a more expensive algorithm, it's almost sure that it will get you a better result. I think that's not always the case, because in a simple situation when the robot only has like a distance sensor, for example, and we want the robot to survive in kind of a maze, I think it's still enough to create like a simple algorithm. Even the reinforcement learning can work with simple algorithm. So again, I think it depends on what you need about the robot. However, I would recommend the reinforcement learning if you really want to build a really autonomous robot. The idea of the disaster mitigation support earlier that I would like to also present, but we don't have much time, is you know, in the disasters, sometimes there are some kind of landscape that human is have a very high risk to enter. Then that's the time for the robots. However, if you look at this kind of dangerous situation, it's unlikely that you will have like a sample data, because you know, we don't have like a after disaster data set, for example, to train our robot previously. Then you might comes to the idea to, can we develop a robot that autonomously can survive in this disasters situation and still help us to get to rescue, for example, some victim at time. So the idea is how to make the robot survive. It's an autonomous robot, and for that idea, I think the reinforcement learning and its derivative is quite good recommendation that I will give you. And if we look at some advanced robot that like a Boston Dynamics has, it's also must I think many of them use the reinforcement learning as well. So
okay, thank you. And I check. Oh, I think almost. Oh, no, almost all question have you answered in this session. I have to check again if any question or comments. I think question or comment. I would like to ask the committee. How about? It's okay? No. Oh. The time is mine around 36 minutes again. If you any question from audience or comment or anything else to discuss in this tutorial, please come in here or chat in the chat box. Or Pak Ibang, if you want to present something, the others research or experience, maybe like autonomous robot, your current work or anything else, feel free to show.
Okay, thank you. Well, actually,
around 30 minutes. Yeah.
Well, that's a much. Okay. Yes.
Your current work maybe, or yeah, anything else?
Actually, we're working on in our lab, we call it the intelligent environment. So, what our research interest is how we can try to create the environment that intelligent enough so that the person or another object or inside the environment can have like a better better experience. So we start with so we're very close with, we're very familiar with robots, and one of the interesting robots that we would like to develop is a smart home. So smart home is a robot that we live in, and the idea of intelligent environment is how to use a lot of sensors to help us to do some things without having to you know interact with the computer. So I think we like to follow the idea of Mark Weiser. So he said something about the pervasive computing, and he said that the best technology the most profound technology is the technology that disappears. It means that you can call it a good or a decent or a great technology if you can't really you don't have to do some configuration. So all of things is do it automatically or in an easy way, and it's quite challenging. For example, we try to compare how to create a smart home for the elder person, and we want to look at some of the comparison between using wearable sensors to detect if he or she and using a non-obtrusive one, the camera. And interestingly, the wearables or wearable samples that we have might do a better job to detect if someone is falling. But yeah, you need still to wear these things. When we try using like a depth camera technology, we use a Kinect for that purpose. We have some interesting data. We can try some kind of well, the problem with the falling detection is that you need to simulate how people fall, and it's quite difficult to do the fall, but we train. And well, there are some things that when wearables is able to detect we are falling, but sometimes it has a false positive if you do some prayer. One of the prayer has a movement of sujud. It's from the stand and goes to prostrate to sujud. It basically put your heads on the floor. If you do it good enough, it's not a good practice. Maybe you're in a hurry and you do this sujud fast enough, and then it will falsely detect as you're falling. You're falling, and we have we can overcome this problem using the camera with the training, and we tell the computer. We try also we use the letter of this is sujud, this is not falling, and then eventually we have a better performance using the camera. So that's a simple idea on how the
and hi.
And our bigger vision will be like the traffic is also should be an environment as well. So as you might already knows that one of our discussion with the autonomous car issue in Indonesia is that we don't really think that it's safe to try like autonomous car that train in well-behaved traffic like in the West and put it on our traffic because there are so many unexpected things in our traffic. So
yeah,
we try yes try to look at another idea of what if we have like an intelligent environment. We have we already have some CCTV. Can try to do some like object detection from there and kind of do some kind of early warning system if there are some not too well behaved, for example, fast vehicle that maybe want to with some rules or other to other drivers so that they will have some kind of alert before the hits, and that's what we call also the intelligent environment. So it tries to understand what happened in the situation and give warning if needed. Of course, it will we need to like have a platform installed in the our cars or our motorcycle to have those communicate with the system. But I think it's also a good idea. And that's the idea of our at the moment. So I think we have too much ideas. It's not
And
good
I
also.
think yeah.
Okay.
Yeah. Oh, I found the new question. Sorry, I check. Eh? Oh, yeah. This one from Utomo Budianto. The question regarding to the artificial intelligence, machine learning, and deep learning, and now reinforcement learning. Since this is just opinion of you. The next generation after reinforcement learning, I think.
Yeah.
What do you think? This like something like dream maybe or idea in your idea after reinforcement learning?
Well, actually, yeah, for humankind, I think it's good that we have like a lot of machine
Yeah.
learning that might help us. It's not good for us as computer scientists because it means you have to study more and it changes every year. So you need to always study them. So from our perspective, it's not always positive. But
Yeah.
I think this is also the challenge. I mean, if you have too many things out there, too many methods out there, we need to develop the skills to pick how to get a better strategy. So we come with better rather than best because it takes a lot of time to find what is the best. And well, you don't. I think the time spent for finding the best should be spent on how to do the better first because if you always look at the best, then you might not experience what is the journey from good, better, and
Yeah.
best. And this experience, I think, is expensive. I think it's a great for our understanding to the future. And I believe the best is coming with also the same journey from the good or maybe bad and good, better, and then best. So what I would like to do in this situation like this, I try to enjoy it as much as possible. Doing something like this, let's experiment with this method. We have a problem like this. Do you have any approach that you can do? We will have several ideas, but rather than discussing of what is the very best idea, let's try first have some experience in it, have some good or better understanding in it, and try to develop from there. And that's also our experience with reinforcement learning as well. So it's got many problems, I think, reinforcement learning. And when I tell my students about the reinforcement learning,
Yeah.
they say something like, can we do not reinforcement learning for our research? But well, unfortunately, they are my students, so they kind of like don't have any other. So, but try to enjoy the moment. What we have here, try what we can do, and try to have like a better understanding because big and complex building of it. So if you just look at from the outside, oh, that's good, that's not, that's good, that's not, then we will never have the experience.
And I found something like a good sentence, and the sentence is like something like this: today's science is future technology. So maybe from the past, before now is we can say as artificial intelligence. Maybe in the past is like jokes or anything else, maybe, or just something guess. something game, like the game theory, like the NES, the Nobel Prize is the NES from Princeton University, the past science and now technology, something like the sentence. And
Yes.
the last question, I think, and maybe last question, I heard the news that Tesla autonomous car accidents happen because it classifies a truck trailer car as the sky. How can we utilize uncertainty for the agent in learning the policy? The
Yes.
wrong detection, I think.
Yes. Well,
This is
I
a
have
big challenge. Yeah.
about the news. Yeah. I heard that I think one of the autonomous car. Yeah, we have some kind of fatality in the autonomous car as well. But yeah, this is new for me. It's also another case of false or false negative, I think. So the truck and the sky is quite different. I don't understand also how come that it will translate the truck as the sky. But the things with the image is that what we see as a human is different with what the computer see. So that's I think the challenge. We have to learn what the computer see rather than what we see, and try our best to translate or understand what the computer see to have like a better classification. And for this case, well, I don't have any comment about that, but I'm the one that also agreed that we don't have to rely all with the camera. So I think we need also to involve other traditional sensors, especially like distance sensors and well anything traditional, but still I think still working. There is also interesting discussion. If you recall the Tesla car, the Elon Musk car, it doesn't have the lidar. The lidar is the sensor that basically it projects a laser around the cars, and it has like it calculates the time travel from the laser to the object nearest it, so that it knows the situation around with using lidars. Elon Musk doesn't want to use the lidars because he's a visionary, and he thinks that, well, if you put a car with lidar sensor and in the intersection, let's just put like 10 cars, all of them have lidars, then there will be interference from these lidar sensors. So it's not good for the future. However, I think what happens with the misunderstand the truck as the sky could be stopped that if we use another sensor like lidar, for example, and or just a simple distance sensor. And the good things is the simulator that I introduced here is using it has like a lidars functionality as well. Yeah, so if you want to experiment with hybrid using the camera and also other sensors as well, then it's also a good platform to do so. So it's quite complicated. We have thousands of data points, and we can't really understand on how to read this data. But you can do that. Still open, as I said.
I think so. And you still remains around 20 minutes, but if no question or answer, I think we the last maybe if you have some comment or message to the audience, how do you think regarding to the new era in artificial intelligence for student or researcher or any people to want to know about this new technology or new science maybe, please your message or something comment maybe. Yeah.
Okay. Okay. Thanks. My advice will be like we need 2 minutes between knows the big picture and try to go deep because well, I think it's useful to sometimes to go to the surface to look at what happens in this like machine learning society or system. What is the use trend? But you can't spend most of your time just look at this development. You need to pick at least one of them and one of your skills because you know sometimes, well, to be honest, actually, in my youngest day, I well frequently have the same feeling like, oh my God, if we have like a development of this method, this complex, is it will be very hard to study all of them, and you tend to try to like what is the best of all of it, so that I don't waste my time to study the best. But I think the question is more about hard work rather than what is your choice is. For example, the video that I present to you is actually an effort that might possible to teach kind of more simple, not more simple, more complicated knowledge like object detection, path planning, and other stuff. You just use neural network and you can solve all the problems. But it turns out that even these methods have some of the weakness, and it doesn't say that this is all obsolete. No, we can still use, even if this method is good enough, we still can use this more traditional in other ways. So the question is how we have some kind of motivation and motivation to learn deeply as well. You still can take the outside and do some kind of small research about what's happening, but I think there is no better teacher than experience. Even if it's a failed experience, I think you can have a better understanding from it. I think that's all.
And I think, yeah, thank you. And I think we should still remember to the sentence, today's science is the future technology. Today's idea is the next technology. And I think this is enough for our discussion and tutorial. Thank you very much for your time. But before we close our session, I would like to taking a picture together, and please make sure that our style is better. I would like to open my sorry, and I would like to count down 3, 2, 1, capture. Okay, once again, I open my glasses. This is looking great. One, oh sorry, and you still your hand. 1, 2, 3. Okay, thank you, Pak Idam. Thank you, Pak Idam, for your time and discussion and tutorial today. I would like to appreciate what you think, what your idea, and so on. And the time is still remain around 14 minutes, but I think this is enough for our discussion. And once again, thank you very much for your time and discussion today. Sometime, I think, and we hope next time we can meet again in the better time and occasion, better time and event. Bye bye and assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Sandar. Waalaikumsalam.
Yeah. Thank you, Pak Idam.
Sama-sama Pak Alexander. Semoga bisa ketemu.
Ya, Pak.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendratari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The Special Region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Tari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Dear everyone, I think since everyone is here, let's get started. Okay, so ladies and gentlemen, welcome to our fourth tutorial. This time, we're gonna talk about deep representation learning for recognizing human and object interaction. And the speaker is Mr. Tomhart Suprapto Siadari. I would like to introduce you to our speaker. So his name is Tomhart Suprapto Siadari. He's from the Wens Lab Entry School, University of Science and Technology. His education background is Master Engineering in IT Convergence Engineering from Kumo, National Institute of Technology, Republic of Korea. His research interest is image and video understanding using deep learning in various applications, including smart city and medical healthcare. His other activities as a PhD student in ICT from Entry School, University of Science and Technology. He's also a student researcher at City and Transportation in ICT Department of ETRI. Okay, so Mr. Siadari, can I call you here? So we're gonna have a video of Mr. Siadari presentation for about the 40 minutes, and then we're gonna have a question and answer session. So for you who already joined in our session, and if you have already a question, you can just type the question on your question tag. I guess that's it for the introduction. Let's start the presentation.
Hello everyone, welcome to this tutorial. So today we are going to talk about deep representation learning for recognizing human and object interactions. I am Tomhart Suprapto Siadari. I'm currently a PhD student in Entry School, University of Science and Technology, Daejeon, Republic of Korea. This is our outline for today's tutorial. I will first give you the overview of human object interaction detection that covers the definition and formulation of HI detection, and then related works, and then problem formulations. And then I will briefly explain the previous works of HI detection, and I will discuss one of our works for HI detection named three-stream network with context convolutional module for HI detection. Lastly is the conclusion to complete this tutorial. Okay, before discussing about human object interactions, we need to understand what the human capability is. So as humans, we can easily perceive and interpret numerous of events involving complex visual cues in our surrounding environments or even from the single image. When we are walking on the street, for example, and seeing a man here like this, moving quickly, sitting on the motorcycle and wearing helmet, we can immediately understand that that man is riding a motorcycle. Or when we are present in restaurant, we can easily recognize associated actions that people are partaking, such as eating pizza, sitting on the chair, drinking a cup of coffee, talking on the phone, and even people paying to cashiers using a credit card. And using the example on this left below, we can take a look at this image and also immediately conduct several visual tasks, such as classify this image as an image of person, or even we can describe that there are person here and then a frisbee in the image, and then also we can point out the exact locations of the person and the frisbee on the image, and then draw a bounding box. For example, red bounding box for person, and then the orange bounding box for frisbee. Or even we can draw more semantic understanding. For example, explain that there is an interaction between the person and the frisbee, which is an action of throwing a frisbee. Okay, let's take a look at this image. There are two images on the slide. We can detect some objects such as a person and then a frisbee and bicycle in these two images. However, there are actually more semantic understanding that we can actually learn from this image. From the image on the left, for example, we can understand that the person is actually throwing a frisbee. And using the image on the right, we can clearly understand that the man is actually riding his bike. So we can actually draw kind of more semantic understanding from images instead of only classification or only detecting the objects. In drawing abilities and capabilities for machines to perceive rich and complex human activities from image is actually one of long-standing objectives in computer vision tasks. So this ability can be beneficial to build up intelligent machines and then offer valuable practical applications as a step towards the future. We can enable and provide greater assistance and services for human beings. For example, a robot in Incheon Airport that can perceive a person holding a huge baggage can automatically offer some helps by calling the porter to carry the human's luggage. Or a self-driving car that can detect the driver talking on the phone can automatically slow down its speed and thus improve the driver's safety. In the future, humans, as social creators, require robots that can understand their behavior and interact naturally in order to live together in society. In order to reach the aforementioned goal, we need to make artificial intelligent machines that can understand how human acts. Human object interaction, or HOI detection, aims to localize humans and objects in images and classify their pair interactions. For example, here, person talking on the phone or person riding a bike on the image on the right, or person skateboarding. So this HOI detection can be formulated as detecting triplets of human, action, and object. HOI detection is very challenging because it contains complex visual cues such as different visual contexts and then different person and object appearances. In order to learn HOI detection, of course, we need datasets. There are two public benchmark datasets for HOI detection tasks, which are VCOCO and HICO datasets. VCOCO is a set of MS COCO by providing the interactions between human and objects and then annotating their action role. VCOCO comprises of 10,000 images and then 26 actions and then about 16,000 person instances. Each person in image has an average of 2.9 action categories. The example of VCOCO can be seen in this image. For example, riding motorcycle, drink using cup, and then talking on the phone, or working on computer, then throwing sports ball, riding bicycle, and then hit sports ball, cut using knife, and then eating pizza. The second dataset is ICOICT dataset. It is a more recent and larger dataset. This dataset is actually an extension of the previous dataset called ICO from the same author, where multiple detection annotations are shown in the image. The ICOICT consists around 48,000 images and then consists of 600 HOIs interactions. It also consists of 80 object types identical to the COCO objects dataset. And then the HOI categories have around 117 action labels, and each of the image has an average of 6.5 actions. And then since each image can have many HOI labels, the total ICOICT annotations exceeds around 150,000, with around the 38 images for the training dataset, and then the other around 10,000 images for test data. There are two settings in this dataset: default and then noun objects, and then also full HOI, which contains around 600 full of the HOI interactions, and then rare, which consists of 138 HOI interactions with less than 10 samples, and then non-rare HOI, which more than 10 samples per HOI categories. This is related works for HOI recognition. It started in 2009 with Gupta, with observing human-object interactions using spatial and functional compatibility for recognitions. So these early works are usually using handcrafted features. More recent works on the HOI detection, it was started in 2015 by works of Gupta. So the visual semantic role labeling. So here is actually VCOCO dataset. So they collected a new dataset, VCOCO, and then in 2018, this starting from that 2018, the works on the HOI detections are basically based on deep learning or deep neural networks. The HOI detection task is also very related, close related with visual relationship detections, with some differences. Compared to VRD or visual relationship detections, the VRD is actually detecting or finding the relationship between object and then predicate and object. There are several predicates that covers in the VRD that includes verbs, for example, where, and then spatial, for example, this object next to this another object, and then action, for example, this object, for example, human riding a bicycle, for example, and then preposition, for example, this human next to the table. Difference from this, HOI detection focus only on human. So this task is human-centric kind of task, which formulated as a human and then verb or action and object. Current and recent HOI detection methods are based on deep learning or deep neural networks. This methodology or these methods can learn feature representations from input images and resulting in more accurate detection results. These methods have led to significant progresses. However, there are still many remaining challenges due to the large variety of human object spatial appearance, and then also numerous interactions coexisted in images. For example, in these two examples, a person throwing frisbee and a person riding a bike, they have totally different kind of visual appearances, which make the HOI detection more challenging. This is typical HOI detection network. So deep learning based network consists of a backbone module and then multi-stream module, which is human and then object, and then human object pair stream. In these examples, there are two. First is from InteractNet, and then second is from HORCNN. For the InteractNet, the backbone is ResNet or pretrans CNN, and then the multi-stream consists of three branches. First is object detection branch, and then human-centric branch, and then interaction branch. And from the HORCNN, the backbone module is pretrans CNN, and then the multi-stream network, it has three branches. First is human stream, and then second is object stream, and then the last is pairwise stream, which contain the interaction pattern for human and then the interacting object. As I said in the previous slide, the backbone module is a pretrans CNN, for example, ResNet 50 or VGG16 or ResNet 152 as feature extractor, followed by another stack convolutional layer with small filters, for example, 1 by 1 or 3 by 3. The characters of the small filters only capture the local features with limited receptive fields. For example, here, if it is 3 by 3, then it will only capture the 3 by 3 area, a local area from the input features. Here, I will explain the HOI detection formulation, or how usually we address the HOI detection task. So given an image I, we first provide human and object bounding boxes or proposals detected by object detectors such as faster RCNN. And then we keep only the bounding boxes that are more than specific thresholds. For example, if the human bounding boxes is higher than 0.5, or the object bounding box is higher than, for example, 0.5. Then by using these proposals, we fit in the HOI detection network. One of the previous works for the HOI detection is HORCNN. It consists of multi-stream network. First is human stream that focus on crop human images only, and then object stream focuses on crop object of images, and then the third is pairwise stream, interaction pattern of human object. In this example, for example, the image contains human object, which the object is bicycle. So the human stream, first we provide the object proposal, object bounding boxes, and then it will crop the features according to these bounding boxes, and then followed and processed by the human stream. And then for the object stream, which is the bicycle, after providing the bounding boxes, the network, the CNN backbone, it will extract the feature informations, and then followed by the stack convolutional layer. And then there is a kind of a last layer to classify the HOI interactions. And then the last is pairwise stream. It is the special kind of two-channel binary images. The first channel is the human, and then the second channel is object, and then followed by the CNN network, typically like two-layer networks. And then these three networks, the loss function will be added, and then the final output score is the HOI interaction. Another recent HOI detection network is ICANN, which is the instance-centric attention network for human-object interaction detections. It follows the same approaches, which is the generate and then classify approach. So first here, the image, we provide the detection bounding boxes using faster RCNN. The author provide the bounding boxes using faster RCNN, and then followed by three-stream network or multi-stream network, object stream, and then human stream, and then pairwise stream. In this method, in their methodology, they provide kind of attention module, which can highlight the instances between the object and then the human, and then for the final score here, the score for the HOI detection is that they add the object and then human score and then multiply by the pairwise stream. So the score is fusion. So they can get the final HOI detection, for example, carry, drink, and then kick and hold and walk and ride. So this final classification is actually multi-label classification. So it means that a single person can have multiple HOI interactions to the object. Here is another type of HOI detection network. Besides using the human and object visual features as input for the HOI detection network, some researchers also add additional features for HOI detection network, such as poses, body parts, gaze, and language priors. This is from the Binji Shu paper. So this paper uses 3 features. First is the visual features extracted by the backbone module, and then pose network, and then the gaze network. Adding these additional features, such as pose and then gaze, it can lead to some improvements for the HOI detection. However, we require more pre-processing time to extract such features for HOI detection networks. Therefore, in the rest of this tutorial, we only focus for networks that are using visual features such as human, object, and then human object features. As I said on the previous slides, the typical of the HOI detection networks consists of the backbone module and then multi-stream module. The multi-stream module is stack convolutional layers. Due to the use of the small filters on the multi-stream network, the HOI detection network can only capture local features with limited receptive fields. So the effect is that the previous method failed to detect some interactions, especially human and distant objects. We provide an example using previous network. Here on the image on the left, it couldn't detect the 2 interactions between human and snowbird, and then snowbird, which is snowboarding, and then also a person skiing. Using compared to our methodology or our approach, we can detect all these interactions. So based on our observations that there was a problem on the previous network, which is using small receptive field, in our proposed method on our approach, we address the small receptive fields problem of the previous HOI detection methods. So our question is that how can we build a deep neural network to learn global and then those more informative feature representations in order to improve the human-object interaction detection? We come up with new methodology or approach named 3-stream network with CCM at context convolutional module. The network consists of 3 streams. First is human stream that focus to learn deep representations for human instances or crop human from image, and then the object stream focus to process the object instances from image, and then the last is human object interaction stream, which focus on spatial relationship between human and object. After getting the features from the backbone module, which is the deep features, we followed the ICANN architecture with some modifications by inserting the CCM. So each branch of the stream, here human and object stream, it consists of ROI pooling and then residual block and then 1 CCM and then global average pooling and followed by fully connected layer. Here we keep still the attention module to highlight the instances, whether it is human and object instances. So the softmax here, the softmax operations is actually to highlight these instances. However, the difference from the ICANN is that we are proposing, or we are using, context convolutional module, which can capture the larger context from human and object features. As for human and object pair stream, it is used to encode spatial relationships between the person and the object. So the architecture is that we first provide two-channel binary image with size of 64 by 64. The first channel is human mask, and then the second channel is object mask. So in human mask, all the human area is valued as 1, and the rest is 0. And the other way, for the object mask, the object area is valued as 1, and then the other area is 0. The human object pair stream consists of 2 layers of CNN, 2 layers of convolutional layers, which size with 64, and then followed by the context convolutional module, and then the last is followed by 2 fully connected layers. I will explain about the CCM, or context convolutional module. So the CCM is actually inspired from larger kernel methods, which proposed by Peng for the semantic segmentation. So the CCM captures larger context information from input feature maps that is relevant to interactions between human and distant objects. So we adopt the combinations of large separable convolutional layers and residual based convolutional layers. So why we are using these large separable convolutional layers? Because directly using large kernel, for example, 15 by 15, will increase the computational process. So it will increase the number of parameters as well. So by using the CCM, we can reduce the number of parameters. This is the architecture of the CCM. So the first large separable convolutional layers is on the left, consists of convolutional layers with k by 1 and then 1 by k. And on the other side, the second separable convolutional layer on the right consists of convolutional layers with 1 by k and k by 1. And then we do element-wise additional 4 outputs of these 2 separable convolutional layers, which end up by k, however with linear computational process. And then these features followed by residual based convolutional layers with small kernel size. The advantage of the CCM is, instead of using directly k by k, which is very high computations, we can keep linear computation process to cover or to capture larger context informations relevant for the human and object interaction. Okay, I will explain and discuss about our experiments. So we evaluate our proposed method, the CCM, using 2 datasets. First is the VCOCO datasets, and then the second is ICO datasets, as I explained before. This is our experiment settings for the CCM method. We generate the object proposals using faster RCNN of Detectron. So we keep only human bounding boxes that has a larger threshold than 0.8, and then object bounding boxes for the object higher than 0.4. For VCOCO evaluation, we train the model for 300,000 iterations with learning rate 0.001, and then with decay for 0.0001 and momentum 0.9. And for the ICOICT evaluation, we keep similar architecture, but we train using more iterations, which is 1.5 million iterations, and then learning rate with 0.001, and then with decay of 0.0001 and a momentum of 0.9. As per our hardware, we are using the Ubuntu 16.04 with GPU GTX Titan Ti 1080 12 gigabytes. And for the CCM, we set the K as a 15, and then the channel middle channel output is 21, and then the final channel for the convolutional features is also 21. For the evaluation metrics of the HRI detection, the AP role of human, verb, and object, a true positive, can be assumed if these three conditionals are satisfied. First is if IOU, or interaction over union of human bounding boxes with ground truth, is higher than 0.5, and then if the IOU object bounding box is also higher than 0.5, and if the action interaction is matched with the ground truth. The evaluation matrix, the overall evaluation matrix is mean average precision, or MAP, for overall the performance. So here in this slide, we report our experiment results on the big crocodile set. So we compare with the recent performance, InteractNet, GPNN, ICANN. From InteractNet, our CCM module, our CCM method has better performance, about 5 points. And then compared to the ICANN, our performance is about 0.6 points. Here, we report again our experiment results on the HiCoDat dataset compared to the recent one, which is ICANN and IHOI. Our proposed method, the CCM, give better performance on the default and then non-objects for full HOI and then non-rare HOI categories for default and object and non-objects. However, for the HOI with rare or limited instances, our CCM has less performance compared to the ICANN. So we assume that our CCM is actually require more kind of samples during the training. And then we empirically show the effectiveness of our design architectures. We retrain the ICANN using only one fully connected layer to get the kind of less number of parameters. So we compare with two settings. First is with CCM on human and object stream only, using one fully connected layer. By using this, even we can get better performance. And then also we train only on the CCM on human and object stream. It means that there is no CCM on the human object pair stream. So by using this setup or this setting, we can get also better performance, about 1 point compared to the ICANN with one fully connected layer only. And then if we apply the CCM on all three branches using only a single fully connected layer, we get 44.8, which is 1 point better compared to the ICANN with one fully connected layer. However, our CCM results in less number of parameters compared to the ICANN even with one fully connected layer only. And the best performance achieved by the CCM on the all three stream branches with two fully connected layers, which is 45.3. However, our model or the size parameters is also the model size is also less compared to the ICANN. So we assume that the CCM, our proposed method, can achieve the better performance with less number of parameters. We show some examples for the qualitative results using CCM. Here, for example, there are person talking on the cell phone and then person holding cell phone. But if we need to filter out this image and then only choose the action interactions for the human, then we need to use the argument maximum here, which is talking the cell phone. And then for the second image, for example, there are two people here. First is the person is riding the bicycle, and then person is using the skateboard. And then there are also several coexisted person interaction with, let's say, ski, and then carrying backpack, and then also serving. So this is kind of qualitative results if we are using our CCM approach. There are also several failure cases which we assume that because the undetected objects from the object detections and also ambiguous background. For example, here, even though the human here is clearly like working on laptop, but our CCM module cannot detect that one. And also the person, there are two people on the image, but however, we can only detect a single interaction or single person. So this is these are some failure cases using our kind of CCM module, CCM approach. All right, this is the end of the tutorial of deep representation learning for recognizing human object interactions. I will conclude with HOI detection is actually still remaining or remain challenging due to the large variety of human and object appearance, and there are several coexisted interactions with an image. Several methods have achieved significant progresses. However, due to the small receptive fields resulting in undetected interactions. So we address this problem using CCM, our model that can learn more informative features with larger receptive fields. So CCM can capture larger context from input features map by adapting combinations of large separable convolutional layers and residual-based convolutional layers. The CCM has less number of parameters because it used fewer large separable filters. And based on the empirical results, we demonstrated that CCM outperforms the state-of-the-art HOI detection methods on two benchmark datasets, VCOCO and ICOICT. As future directions, there are several points that we can discuss. First is detecting rare and then unseen objects. Because we can see on the VCOCO and ICOICT, the data containing the rare objects is limited. And also improving the detection performance in rare objects can increase the overall performance. And there are many objects actually in real-world applications besides the 80 objects from VCOCO. So the possible methods here, we can use, for example, zero-shot learning and meta-learning. As additional informations, you may also look at the recent papers in 2019 to 2020. There are several good papers from big conference such as ICCV and CVPR that are discussing about the HOI detections. It may be very helpful. And this is references in this tutorial. Hopefully, this tutorial can be helpful for people who are interested in human-object interaction detections.
Okay, so that's the presentation from Mr. Tom Hurt. So here you are, Mr. Tom Hurt. How are you?
Hello, thank you for asking. I'm doing well. Never been better.
Wow, you're from Korea at the moment, so.
Yes, I am.
Oh, okay. Well, I guess you have a better situation than here, but okay. Anyway, good to hear that. Yeah, okay. So, Mr. Tom Hurt, I think it's amazing to look at how simple things for human turns out to be actually very complicated for machine, right? I mean, like we understand the human and object interaction at instant, right?
I don't know what happens in our brains to make that fast conclusion, and why the machine took so long to conclude what happens between human and object. So while we waiting for the question, could you have or elaborate more idea about this? Why machine is so difficult to do some simple things that human is very easy to do so?
Okay, that's a very good question, though. In computer vision, I guess, in general, not only in the human-object interaction itself, the computer or the machine, it's very difficult for them to understand the human, to understand the objects, not only human or not only to understand the visual sense, because there are several factors, right? On the human, on the machine only understand the visual context as a kind of pixel or numbers, right? And to understand these numbers is difficult because there are many kind of additional factors, such as, for example, lighting, and then also point of view, and for example, like illumination, for example, that adds more difficulty for machines to understand the objects or the visual context. And the algorithm itself, because we are in this tutorial, we are talking about, for example, specifically for deep learning or deep representation learning. And before deep representation learning, there are many researchers already, they address the kind of, let's say, object detection or several computer vision tasks. The simplest, I don't say it's simple, but the simplest task, for example, like image classification, before 2012, before the deep learning breakthrough, the progress from that challenge, ImageNet challenge, for example, is very kind of very limited, only small progress. So that's why I guess it's also depend on us, like human, because we are human, that we built this algorithm, right? And then we put to the machine to make the machine understand. But however, I think from the algorithm point of view, there are much progress, and especially by the availability of the dataset, and also the availability of the computation powers. And also the reason why somehow previously it was very difficult for machine to process all these things. In terms of algorithm, I think it's not that new, right? If our seniors, like, they learn about AI since, let's say, 20 years ago, this algorithm is pretty similar actually. However, the data and then the hardware are different. That these two factors are mainly the most fundamental, the most influential factors why we can achieve this kind of progress.
Yeah, I agree with you. Especially the breakthrough of deep learning, it really changed the world. So, and it gives us more material to study as well. Okay, so
That's
here
true.
we have first question. So to Dr. Tom Hertz, do you consider about domain adaptation? Since many methods in HOI detection are existed in the worldwide, but studies mostly is a common or public dataset. What are the factors to be considered to apply such methods in any domain and environment?
Should I answer right away, or?
Yes, yes, please.
Okay. Okay, that's a nice question as well. For the domain adaptation, since I said in my presentation, actually, there are mainly only most popular datasets right now, only two, like VCOCO dataset and then HICODAT. The VCOCO itself 2015, and the HICODAT maybe 2017 or 18. And since then, it's been only, let's say, like 3 years, right, since 2018, and the progress on the HICO dataset is very still the performance is still low, about 20% only. So there are many kind of research opportunities, including the domain adaptations, because in the HICO data itself, it has kind of very, what is that, long tail distribution. So there are several kind of HOI that has only very limited data set. And as the questioner asked, that person asked about the domain adaptation, there are many data on this word that we couldn't kind of annotate, or we couldn't collect the data, and then we train the model, HOI model, for example, to solve this problem. So the domain adaptations, if we can adapt to new domain or new let's say, new domain or new field, that's going to be, I guess, a good opportunity for research wise and also in implementation. So there are a lot of kind of open research opportunities for this HOI, including the domain adaptation.
Yes, and particularly if we use the same data set, it's easier to compare the performance, right? So I think the data set is a good place to start. However, yeah, I agree with you. If we have like a domain adaptation and we can bring this like an innovation outside, and well, but I think yes, you're right about if is there any possibilities to generate our own data set, considering that we have like many CCTV available here.
Okay, so there are several, I guess, there are several researches already, papers. They address the HOI detection not only using the data set, but also like unseen objects, for example, using zero-shot learning. So I believe that some researchers already, they have kind of, this is the domain adaptation is one of the direction, the additional direction, the advanced directions for the HOI detections. And there may be, I guess, about 5 papers already discussing about this, using zero-shot learning for detecting to detect unseen kind of objects.
Yes, and oh yeah, we also have a problem of, I think, the annotation as well if we want to generate our own data set, right? Because I think it's
that's true.
That's a lot of work. And
yes,
I think,
true. Collecting data set is expensive.
Yep. Yeah, that's one of the weaknesses. We still have to do that, unfortunately. Oh, so here another question from the same person. So the one who asked is Mr. Mahmoud Celestio. So his second question is, I think the XOI is important in realizing a smart city nowadays. However, applying XOI methods in public space may cause privacy issues or human loss. How do you consider this?
Okay. Okay, I just see that one. Okay. Actually, this HOI detection in my lab is part of we have in the lab is smart city project, and one of the solution that we address is using HOI detection. However, we did not specifically apply or implement this HOI detection into real services because there are several kind of limitations, especially for the real-time problem. And then the question about the privacy, right, for the in the public space, for example. That's true, I guess, not only about the HOI detection, but however, in many applications, such as like video surveillance or face recognition, for example, or person identification on the public space, it is an issue for us, for the computer scientists in general, for the computer vision. But I guess we can come up with several solutions, for example, and then this is also a very good question from the audience, right? because I just get somehow an idea. For example, we can implement this by using, for example, by using low resolution images. You know, the privacy, it can be also addressed by using the low resolution images. So capturing the audience, I mean, capturing the person or people from the public data set, but only using very low resolution. So we didn't see, we will not see the face or the person exactly. And then through this process, we can use that as input, and then we can process using, let's say, existing HOI dataset, HOI model. Then we can get, well, that we can address a new problem here. So as a researcher, we can publish a new paper, for example, using this kind of problem setting.
Wow, interesting idea. Yes, I think you're right. It's also a good solution as well. But yes, I know to blur somebody's face will keep he or she his or her privacy, and I think it won't affect the HOI algorithm in detecting like human and skateboard, for example. But do you think if we blur the image, does it have something that affect the performance when it tries to detect like somebody sip coffee or drinking something? Does it have something to do
I
with that?
believe it does. I believe it does. It affects the. it will definitely affect the performance. However, that's kind of one of the challenge that we have, and then we have to address, because if we want to implement in real implementation, there are many kind of situations that we cannot predict, because dataset, actually using dataset is somehow like the best data that we have, right? It's totally different from the real implementations. In terms of research and publishing papers, of course, we need to use this dataset and then compare with others, so we can track and then compare our proposed method into others, right? But in terms of, let's say, technical implementation, that's going to be a different story.
Yeah, right. Yeah, talking about the use of this innovation as well. Do you think it's realistic to expect a kind of criminal detection as well? I mean, that's one of our problem, and there are some or maybe many criminal activities around us that gets on CCTV, but we don't know. Do you think it's possible to extend this work into kind of like a criminal activity detection?
Okay. I believe it could be one of the solutions, because there are many other also solutions for the detecting the criminal, let's say, for example, video anomaly detections. That is also one solution in computer vision kind of task. And for the HOI, for the video, it's also one of the kind of directions for research progress. However, the main bottleneck here for HOI detection on video is the dataset. So we need to address this problem using unconventional way. For example, right now we are talking that kind of supervised learning. We have dataset and then we address it. However, if we want to enhance this HOI detection into video, I guess we need to address this using another way. For example, using weekly supervised learning, it's also possible, because this HOI is quite new compared to, let's say, object detections or semantic segmentations. So there are many opportunities.
Well, okay, thank you for your answer. Okay, so we're still waiting for another question. So, Mr. Tahmad, tell me, I try to have like a simple way to see your work as, so basically it tries to detect the person first, and then detect the object, and then tries to predict what is the relation between the human and object. Is that true? So,
yeah, that's true.
What
I think you already explained in the technical technical details. I just want to grasp the big picture about how come your methods is able to have like a more informative, I think more global detection rather than the available or the previous methods like ICANN. Can you tell us about what is the unique about your box that make it better in that way?
Okay, so based on our observation, so we use the existing methods such as ICANN, for example. So using this ICANN method, we couldn't detect all the kind of specifically human and distance objects. So we end up with new idea that we want to use. There are basically, for example, like attention module, and then this large separable is like using the, if people understand the way the convolutional layer works, so it is typically using kind of small receptive field, for example 1 by 1 or 3 by 3, usually 3 by 3. That's kind of very normal. And then this 3 by 3, it has kind of, it's sliding, right, sliding to the several regions, and using this 3 by 3. However, it only captures very small region, which is 3 by 3 itself. If we want to capture larger context from the features, we can use, for example, 7 by 7 or 9 by 9. However, it increased the computation process by 9 by 9, and then it's sliding that way, right? I mean, sliding that way to capture larger areas. So is that based on the stick segmentations methodology, we use this one. So we can use 1 by k, for example, instead of k. So by using, for example, first 1 by 15, we can capture this one, and then the other branch using 15 by k, and then combining this, somehow it is similar to k by k, however with linear computation process. So that's why we capture larger by using larger filters here. Basically, the convolutional layer filters that we are using is different. We have larger filter that usually people using 3, but here we're using 15 by 15. But since it is quadratic 15 by 15, it is very large, is heavy computation. So we use large separable, which means k by 1 and then 1. If yeah.
Well, I think it's clever idea. I mean, so your solution is done into the very I think the very foundation level of the image processing, right? I mean, it's about the kernel from from you try to enlarge, but if you enlarge it big enough, then it will have a problem with the computational power. So so the solution will be how about to have some separable layers, right? To do that. Wow. Have you ever been compared this or your approach with other? Is there any other methods than ICANN that you can compare to?
Okay, so we compare with previous methods. There are several. However, I haven't updated with 2019 and then 20. We also have another kind of solutions instead of CNN, instead of CCM, but still we address this small receptive problems, because we think that by using larger contexts, we can learn kind of global informations from the input features. So we compare on our paper. Actually, we compare with maybe from the ICOICT data set, maybe four or five methodologies, previous methodologies, and then for the ICOICT, maybe similar, like 4 or 6 previous methodologies. And by seeing this, like only 6 or 5 or only 4 methodologies, it means that this HOI detection field it has not been investigated very well on the computer vision task, and it may, I mean, there are many opportunities here. So if you have enough, let's say, research equipments, for example, to simulate these things, then I think it's kind of good direction to compete with others on the, let's say, this is research. I mean, we are talking about research on the research paper, for example. It's very, because it's somehow, it's not new. As I said before, there are several previous works that investigated using handcrafted features, but using deep learning, it was started maybe in 2015.
Okay. Wow. And how does it perform? I mean, does this approach like beat all of others methods, or does it have some kind of stiff competition from other methods? Or we're talking about this. I just wondering as how good it is, and well, how exactly you measure this performance?
Okay, so compared to others, we have comparable. I said comparable. It's better, but slightly better in terms of the computer vision task. If people working on this topic, increasing 0.1 or 0.2 performance is very challenging. It's very hard actually to increase even the performance 0.1 or 0.2. It's very challenging to increase like 1 or 2 points using your proposed methods. It's challenging. This is the I mean the truth that we have to face. So somehow people think that 0.1 or 0.5, it's not big, right? However, it's difficult. If you are working on the image classification or object detections, it's very hard to increase that amount of numbers. And then sorry, I forget the second, the following question.
How you evaluate the
measure. Okay, right. So we are using the precision average precision matrix, precision matrix for every action, for every interaction class. So it ends up with mean average precision. So the precision itself, it is considered as a true positive if the human bounding box is higher than 0.5, and then if the object bounding box is also, I mean, the IOU between the ground truth and the prediction is higher than 0.5, and then the IOU, interaction over union, of the ground truth and then the predicted bounding box is also is higher than 0.5, and then also the interaction prediction is matched with the ground truth, then we can say that this is the true positive, and then we measure the precision based on this.
Oh, wow. Okay. Okay, so here's Mr. Mahmoud Sulistyo again. Thank you for the answers. I think the idea of using low resolution image is a good idea. Okay, yeah. Alternatively, you can also use another type of camera, for example, a thermal or thermal image or sensor camera. I think I think it's great. Thank you, Mr. Mahmoud Sulistyo, for the input. And here we have another question from Muhammad Iqbal. I would like to know for the best detection. So the question involving the best is always difficult. I would like to know for the best detection, how do you separate the pixel segmentation if I have 7,500 multiplied by 700 by 7,500? If 15 x15 is very small, any solution for the big data? So I think the question is about the representation. Can you read the question as well? From Mr. Muhammad Iqbal.
Okay, sorry. So the question is that the best objects detection?
No, so actually
Sorry,
it's
can you please repeat again?
so segmentation. How do you spread the pixel segmentation for a bigger dimensions? Let's consider 7,500 multiplied by 7,500.
Images?
Yes, it said so. 15 is very small, so any solution for the big data.
Okay.
I think tries to does it
Okay.
yeah, the problem with the bigger image can we deal with this bigger image because it's far bigger.
Oh, okay. Okay, so can we deal with bigger size of image?
Yeah,
Is that true, the question? Okay. So since we resize, of course, before feeding the network, we need to resize the input. That's kind of, I guess, very typical way for the computer vision task. So of course, feeding the larger image is also possible. And the performance, I don't think it's going to be it's going to be affect that much by using the high, let's say, bigger or larger image, because at first this is kind of two stage. If you understand clearly about the HOI, first we need to provide the bounding boxes or object proposals using object detectors, and then by using this information, and then we feed the HOI detection network. So yeah, it's possible, but yeah, it's possible. And then because we have kind of resizing, we need to resize the input during before feeding the network.
Okay, or put it another way, instead of 3 multiplied by 3, the kernels you use is you said that you enlarge it into like a 15 by 15, right? So maybe the question is also, what if you just enlarge it far bigger? I mean, like 1,000 by 1,000, for example. What will happen if?
Oh, okay. The filters, the kernels.
Yeah, right.
Okay, because the dimension. Okay, we need to think about the input as well, because the input doesn't kind of that big actually. So after getting the feature maps from the ResNet or the pretend CNNs or the backbone module, the maximum size probably only like 15 by 15. That's the kind of 15 by 15 because it is extracted features already. And then we are using ROI pooling as well. We are using ROI pooling, so it doesn't really need to use that kind of big, I mean, that such large filters. And if you are working on the segmentation, this is also typical. If in the middle of the, in the middle of the network, CNN networks, for example, here, typically edge and height and width are not that big, right? In the middle, intermediate layers, maybe only the depth that is the maybe like 500 or 1,000 channels, right? So by using these large separable kernels, actually you can also, why we end up with less number of parameters, because we are using less number of channels. So for example, I use here like 15 by 15, but usually people use 3 by 3, and then there is an output channels, right? Usually maybe like 500, let's say 512. However, in our method, we only use less than that one, for example, 100. So that's why we end up with less number of parameters here.
Okay, and I think that led to the question about the computing performance. Do you also measure the performance? I mean, either the training process. Is it longer than other methods?
Okay, we didn't measure the exact time for training to for our method. However, we compare the number of parameters, not size. Not on my presentation, I compare the size, weight, size. However, compared to, let's say, ICANN, because in this research, only ICANN like share their codes, so we can get the weights, and then we check the parameters from their method. So we get less number of parameters during training. So their method maybe about 15 millions, I guess, parameters, but ours maybe 46 million parameters. So we have less number of parameters. However, having during training, it is possible that our method kind of has less time, or I mean faster convergence. It's possible, but since we don't measure, so I couldn't kind of say much about it, about this issue.
No, okay. So I saw your presentation about how it involves like is it possible for your system also to detect like more than one person interact with one object? Is it also possible?
Yeah, it's possible. It's possible. However, it is the more objects or the more human that we have, it requires more computation. I mean, more precision time. However, it's possible since we collect, for example, let's say all the humans detected on the image, we can get the interactions that has, let's say, for example, more than 0.5 thresholds. So we can get that one. It's possible.
Do you test like how many the maximum numbers of humans that your algorithms can take? I mean, just to look at how it's also feasible to implement
Okay.
on higher situation or critical situation.
Okay. 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 Because in this case, actually, this is also one of the let's say bottleneck or research direction that we can investigate more. Because if people understand the object detections, also they have to in here is like kind of pipeline. First, we need to detect object detection first, and then followed by the HOI detection network, which is depends on the object detection performance, right? So number of objects, right? Number of persons and number of objects that can be fed to HOI detection network depends on object detection performance itself. So the better object detection that you can use, then of course the more human, let's say, and the more, I guess maybe the more, of course, the more human and object that you can get. However, doesn't guarantee. I mean, it's not necessarily that you can get better. I mean, more interactions from this. So if you can make this process as one single pipeline, let's say using object detection directly followed by HOI detection, and then, or you can make another branch for this, then it's going to be another way to solve this HOI detection problem using only single object, single process, single pipeline.
So you're saying that it depends on the previous stage, right?
Object,
because,
yeah.
it depends entirely with the object detection. Yeah, I think so. And what about the the set of the prediction? I mean, do you already have like a predefined set of relationship, like somebody sip of coffee or bring a cup of coffee? Do you have a list of this classification before?
Yes, we use actually prior information, prior knowledge, but it is related to interactions and objects. For example, if it is riding, for example, if the object, I mean, if the verb or the action is riding, ride, the object pizza, for example, pizza is not related. So we drop this right away. So we provide that kind of prior knowledge for faster inference.
So
for faster inference.
You do kind of like a filtering before. It depends on the context.
For faster inference, yes. For faster inference.
For
But
example,
for training.
For example, if well, this is a pencil, and usually the relation with me and the pencil is writing, right? But if I put it close to my mouth, for example, does it will conclude that I'm eating or I'm consuming this pencil as well? Is it possible in this scenario?
It probably it could be because the performance is still low. So there are many contexts that we can add here. For example, like pose, for example, that can get more kind of understanding or information for the network to get better interaction detection. It's I mean, if you said it is possible, yes, it is. However, because the gesture, it's very similar, right? So it is something like, let's say, cookies, for example. So yeah, that's possible. So there are many factors that we investigate for the HOI detection. For example, learning the context by using, let's say, pose, for example, pose, or using gaze, like gaze, because it is also including the interactions, right? Or object that we can interact with. And then you can also using like attention module to learn this context information is also possible. So there are several, there are more, because the VCOCO, let's say VCOCO dataset, the performance is still around 50%, 50% MAP, I mean precision. So there are a lot of works that we need to, there are a lot of works to be done actually for this research area. It hasn't been matured very well.
Because previously I think like can we make like another early detection system for a baby? For example, if somehow baby put something in his mouth and it's not supposed to be a food, and well, yeah, because we work with the data set, I guess we can only work with what is the available with the data set. Oh, we have a last question from, okay, the first person, Mr. Mahmoud Sulistyo. Maybe also for me. Oh no, I'm a moderator. Okay, how do you compare the current technology infrastructures in Indonesia and Korea, where we live now, in related to applying such emerging techniques? So it's yours to answer, Mr. Tom Hurst.
The difference?
Yeah, compare the infrastructure. So
the current technology architectures, infrastructure. Wow, that's infrastructure, right? Okay. What should I say about this? That's a kind of okay. Okay, that's a question. I don't know whether I can give kind of clear or sufficient answers for this. However, because I haven't been in Indonesia for quite long, so it's been 9 years I have been living here, so I have no kind of a hands-on experience as a technology for Indonesian architecture in Indonesia. I guess a lot of progress and a lot of advancements already have been done in Indonesia, and compared to current technology infrastructures, maybe I can say about, for example, the telecommunication network, kind of let's say 5G, or yes, 5G. Let's say 5G. In Korea, it has been commercialized. So there are operators already, for example, like in Indonesia, Telkomsel or Indosat or others. In here, there are several operators. They have commercialized this network. And then also the smartphone, of course, it supports from Samsung, LG, this to, and of course it increased the let's say throughput and also the speed, of course. And by using this infrastructure, they can also enhance with new services. This my project right now is smart city actually, but over 5G network. So it's a kind of one of the not only smart city, but however using 5G network. So we want to deliver services based on this 5G network. That's kind of also, you can clearly see the difference here. We want to, in here, we want to provide service already based on, let's say, AI technology for the smart city over the 5G network. By using even this statement, I guess it's already, it's different. It's different. How do you compare that? I compare by using this only statement. Then I guess audience need to kind of interpret their ways, because I couldn't say clearly or specifically here. But however, I guess in Indonesia, I believe there are kind of promising. It's promising in Indonesia. There are a lot of talents, such as like Dr. Idam and Pak Mahmud. There are a lot of talents in terms of, let's say, research directions, and also for the infrastructure. I guess also we have kind of promising kind of talents as well to make this possible in Indonesia.
Yeah, maybe I can add some. Well, because you're not in Indonesia for quite 9 years, so I want to let you know that we are still in 4G at the moment, and we don't know when if we want to implement the 5G. But well, the problems and I think the advantage of Indonesia is also it's a very big country, because well, in the big city like in Bandung or Jakarta, you will have like a faster and better connection infrastructure. But there are also few villages in our country that maybe they haven't really familiar with the internet. So especially in the situation like study for home means literally like holiday for them, because it's how are you going to conduct this education using some very advanced technology that relies on good connectivity if you don't have the infrastructure yet. But I guess we're that way. So I guess that's the situation. And from the researchers' point of view, I think both have some the advantage as well, because the data and the connection that we have here is also suitable for research that we want to develop here. So maybe we kind of like this is a little another question, like the data set, I believe, is using like foreign data set. How do you think it performs when we go to be implemented in Indonesia? So I one of my colleagues have presented some kind of also the face detection, but the data set is using like a foreign face, and I think it doesn't work very well if we implement it with using the Indonesian face. In the case of human object interaction, what do you think? Do you think it's the available data set? Do you think we can still use it for the local implementation?
Okay. I have very limited knowledge about this. However, I will try to answer. Since the first encounter is the object detection itself, so I heard that the object detection, like let's say like faster RCNN or YOLO, they don't really work very well as well in Indonesian environment, because the visual context is different, as I know. That's what I know. So I believe maybe it will affect the performance itself because the objects are not person. I mean the interacting objects based on COCO. So there are many also interaction. I mean there are many objects in Indonesia that have visually different. So it may perform differently from the research reports, from the paper reports. And yeah, that's the reality for the, let's say, computer vision in general as well. Doesn't really work that well. However, I believe, I don't know, do you somehow the AI itself also, they have kind of bias, right, in terms of this data? Not bias, like the performance very good on the data set. However, it doesn't necessarily true for the real world implementations. Then I believe there are some other researchers in Indonesia that they have to address this kind of question. So yeah, that's what I can say.
Yeah, and it leads to and I think an opportunity to develop our own data set, for example, because we rarely see people with like a surfboard here. So I think if you implement it in Indonesia, it will misclassify it as surfboard. But Indonesian rarely use the surfboard. But I think
Right.
That's Indonesian.
That's true.
Doing stairs, for example, or a long object that may be different. So I'm not worried about the human part because I think the posture may be still same, and we rarely seen human and object interaction, something to do with its face, his face or her face. So it's about the posture, but yeah, the object might be different. So I think good idea also to build. Or what do you think?
I have a comment as well about this, about the data set, especially about the data set. So in terms of this HOI detection, also I believe it's as you said, it should be an opportunity for us actually in Indonesia. We can define our own interactions, human object interactions. For example, let's say, of course, on the VCOCO there is no, let's say, beca. There is no beca. There are many type of motorcycles in Indonesia as well. So if this is, of course, it requires I don't know, the, let's say, funding or others, right, to collect this data set. However, if we can develop such data set for example, object detection or for this human object interaction detections, this is ideal kind of ideal conditions. However, let's talk about this ideally first. So if we have this data set, then there is also opportunity for researchers, lecturers, or professors in Indonesian university. We can have a comparison performance, right? So for example, researchers from our lecturer professor from UGM, they publish papers using this our local data set and managed by them as well, for example. And then another researchers from Telkom University, let's say, they propose a new model and they can compare with the previous method, right? And then we can get kind of comparison and steady progress on this data set. And that's going to be very good in research wise. And also it tackles the let's say local problems in Indonesia to detect the interactions, for example, that locally happens in Indonesia. That's, I guess, very good directions if there are some people that want to develop or to collect this kind of or to conduct this kind of research.
Yeah. Okay, I think wow, this is a productive discussion. We have a lot of ideas actually. So this talk lead to another idea to another research. So I think it's a never-ending loop.
But thank you very much, Mr. Tomhead, for the insightful presentation you have here. And I think before we close, I think we need to memorize this event by taking a picture together. So I guess the house is ready. So let's give us a best smile. I'm going to count on 2, 3. 1, 2, 3. Okay, another one. Using this hand. 1, 2, 3. Okay. Well,
Thank you very much.
actually didn't hear anything, so hopefully they record our face. And it's a pleasure to meet and talk to you like this, Mr. Tomhat. Hopefully we can have another meeting, hopefully in person in a better situation. And I think that's from us in this fourth tutorial. And after this, we have a break for about 1.5 hours. We will start another, I think, parallel session, and we will have 2 sessions actually. In room A, there will talk about new trends in image video super resolution conducted by Dr. Muhammad Haris. And afterward, at 3 o'clock, we're going to discuss also about deep learning and its application in video analytics by Dr. Lim Kian Ming. So it's still a long day and many insights here. So hope you can still be with us to discuss very interesting things like this. So I think that's it all. And thanks for the audience who joined us in this presentation and for the questions, and also for the host who facilitated our discussion today. That's all from us. See you some other time. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Idam.
Yeah, Mr. Fahad. Yeah.
methods and the
Good evening. From the out of the handshake,
Dasar kowe bocah gundul pola mujian ora berdoa. Dasar kowe bocah gundul tumidan ora dengar. Bocah Dasar kowe bocah gundul pola mujian ora berdoa. Dasar kowe bocah gundul tumidan ora dengar. Bocah Dasar kowe bocah gundul pola mujian ora benar. Dasar kowe bocah gundul tumidan ora benar. Bocah gundul pacul gundul pacul gundul pacul gundul segani jadi sarata segani jadi sarata dasar kowe cakundul dasar kowe cakundul obra gundul pacul gundul pacul gundul pacul gundul segani jadi sarata segani jadi sarata dasar kowe bocah gundul pola mujian ora benar. Dasar kowe bocah gundul tumidan ora benar. Bocah
The special region of Jakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parang Tritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendratari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Gambaran bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai berdampak.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south of the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical things. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendratari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai mendapat.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south of the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendratari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Gambaran bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai mendapat.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family live. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south of the Keraton Yogyakarta. And of course, there is also a public research university accredited as one of the most prestigious universities in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, There is also a temple called Borobudur, the largest Buddhist temple in the world. To reach to Jakarta, government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Jakarta also have traditional dance called Sendra Tari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Gambaran bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai terdapat.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university accredited as one of the most prestigious universities in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendra Tari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Gambaran bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai berdampak.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
Kalau seringnya eksis, ini kan bukan di sini dulu sih. Ini kan eksis kan, juga pasti semua ini. Lu lari ke A2 malah.
Okay, within 2 minutes, we will start the tutorial. Now is already 12:58. So within 2 minutes, we will start. Okay, we can start because this is already 1 p.m. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, first of all, my name is Wayono. I am from Universitas Gadjah Mada. So it is my pleasure to be serving in as moderator for this tutorial session. So for this session, this tutorial session, we will have two parts. The first part will be playing the recorded video of presentation from the presenter, and then the second part will be question and answer. So for playing the video, the maximum time will be 40 minutes, and then for live question and answer will be minimum is 20 minutes and maximum is 40 minutes. So during the playing the video, if you have any question related to the paper, please ask using chat panel. And then later in the live QA, I will read the question and ask to the presenter directly. So for this session, we will have the title will be the new trends in image and video super resolution. The speaker is Dr. Engineering Muhammad Haris. So Dr. Engineering Muhammad Haris, he is currently the AI Research Manager at Bukalapak. So he got the Sarjana Computer from Faculty of Computer Science in the University of Indonesia Depok in 2009, and also he got the Master of Engineering and Doctor of Engineering degree from Department of Intelligent Interaction Technology from University of Tsukuba, Japan in 2014 and 2017 respectively. So currently he is He was working as the postdoctoral fellow in Intelligent Information Media Laboratory in Toyota and so on. Besides that, he also served as a reviewer for several journals and conferences such as IEEE TPMI, IEEE TIP, IEEE TNNLS, and then also CVIU. So maybe we can just go to the first part. The first part will be the playing the recorded video from the Mr. Harris. So the maximum will be 40 minutes. Please play the video.
Hi everyone, thank you for attending this tutorial session. My name is Muhammad Haris. I currently working as AI Research Manager at Bukalapak. The topic of these presentations will be new trends in image and video super resolutions. So let me briefly explain about myself. I was graduated from University of Indonesia, Faculty of Computer Science, and then in 2012 I continued my study to University of Tsukuba for my master and doctoral degree, and then I also did my postdoctoral researchers at Toyota Technological Institute in Japan, and now I'm continuing my research as AI Research Manager at Bukalapak. So today we have three topics: image super resolutions, video super resolution, and also space-time super resolutions. Let us go to the first topic, image super resolutions. So what is image super resolutions? Actually, it is very simple to understand image super resolutions. The objective is to enlarge the input image to some certain high resolutions. Let's say in this sample, we have input image A, here very small image. We want to enlarge to some certain size. For example, this one, we see that we have blurry and not sharp images, which not visually good to see. By using super resolutions, we can enhance the details in the images. For example, this one. We can see the image visually better than the previous one. That's the objective of image super resolutions. So what? So now I will introduce our methods, which call deep back projection networks for super resolutions. This paper published at CPPR 2018 and also IEEE PAMI journals in 2020 recently. So these methods also won several challenges in 2018 and also 2019 on super resolution image, perceptual super resolution, image enhancement, and also extreme super resolutions. And also the code is available in the net in the internet in the GitHub, so every one of you can try to use this method. So what is the difference between DBPN and the existing super resolution networks? I categorize the existing super resolution into three categories here. A is predefined upsampling. In the predefined upsampling, they use external upsampling operators such as bicubic to interpolate the input image, and then they use the neural network to map the nonlinear relation between the interpolated image to the real ground truth. So here they only fill the details of the input image to the ground truth. And B extract the low resolution features directly from the input, and then finally they upsample the low resolution feature maps to produce the high resolution images. And C is actually the extension from B. If B directly upsampling the scale, for example, 8 times, they directly upsample to 8 times, while C is progressively upsampling the input For example, if we want to perform 8 times, they will upsampling 2 times, another 2 times, and another 2 times to finally produce the 8 times super resolutions. So what is our basic idea? Let's say if we have L in low resolution images, we want to enlarge the image. Our task is to fill the details of this question mark, which is there's so many possibilities to fill, and there's so many numbers from 0 to 255. So super resolution is categorized as ILPU's problem. Since we want to produce the best result, the optimized results, it is hard to see what is to optimize the network itself. Therefore, we create another mechanism, which is downscaling back the output image to low resolutions. The intuition is, let's say if we have small image and then we want to enlarge the image to high resolutions, to check the consistency between high resolution and low resolution image, we can downscaling the high resolution image back to the low resolution image, and then we can see how big the difference between L and L hat in this case. By checking how different L and L hat, also it means we provide direct cycle relations between LR low resolutions to high resolutions, and then again back to low resolutions. So these mutual relations within low resolution, high resolution, and then back to low resolutions will provide stronger relations between low resolution and high resolutions. And of course, also we can iterate this cycle several times to provide stronger relations while minimizing the error between L and L hat. Then finally, we come up with these architectures. We call it DVPN, Deep Back Projection Network. The input is single image, and then we have set of up projection and down projection module, which present the mutual relation between high resolutions and low resolutions. Here, the up projection will produce high resolution feature maps, and the down projection will produce low resolution feature maps. And then we concatenate all the output from up projections, which is high resolution feature maps, to produce the real high resolution images. Here's what happened inside up projection unit and down projection unit. The input is LT-1 for up projection unit, which is low resolution feature maps. We upscale it and then we downscale it back to L0T. Here what happened, we calculate the error reconstruction between the initial low resolution feature maps and the interpolated low resolution feature maps, L0T and LT-1. After we get the error reconstruction, we enlarge the error and then we sum it back to the initial high resolution feature maps from the initial features from the initial input, and then we get the refined high resolution feature maps, which we call HT. The same procedure also has been done for down projection unit, but the input is high resolution feature maps, and we get the refined low resolution feature maps, which we call it LT. Here's some sample of the results from 8 times enlargement. LR presented as the input images. We can see that we visually human even cannot predict the real pattern behind these images. If we see the ground truth, the high resolution image, which is the left images, HR, and compare with the result from the methods bicubic, Laplacian, SRN, EDSR, and ours. we can see that bicubic failed to improve the images, while Laplacian and EDSR can improve the input image, but the result is still not satisfying. We can see in the first row that Laplacian and EDSR fail to interpolate in the correct direction from the ground truth. It predicts as diagonal pattern, while ours correctly interpolated as vertical and horizontal pattern. Also, the same situation happened for the second row and also the third row. In the third row, although the shape of the hole is quite different with the initial, the real ground truth, but if we count the holes, we have the same number of holes produced by compared to the ground truth. Here again, we want to see the effect of our methods on animation set images. We can see that low resolutions contains so many noise, blurry effect. Here again, we see that ours is can produce very sharp, and we can see there is the separation between the lines in the first row and the character, hiragana character, is very sharp, whilst it is failed to distinguish in the other methods, DSR, Laplacian, and also bicubic. In the second row also, we can see that there is fine details here that successfully refined by our methods. And also in the third row, above the eye, is very sharply interpolated by our methods. Here the result of the full images. Again, the input is very blurry, and the result of ours is visually much better than the input image. And also the second results here, if we see the input, maybe we fail to count how many person inside these images, but after we use our methods DBPN, we can see that other than these 3%, there are another person behind them. And also these images, it's usually worse than ours. We can see it clearly much improved, the input images. So I want to talk again about DBPN improvement. We can see that there is several improvement that can be done for our network. Two of it will be explained here. One is using the recurrent DBPN with shared parameters. If we still remember that the initial networks using separate weights for up projection and down projection units. We also think that we can share the weights for up projections to the next up projections, and also down projection, the same will be shared to the another down projection unit. So in this case, we will reduce amount of parameters that will be utilized in the network, and also we can avoid the use of dense connections since all the parameters is connecting each other. So here we can improve the network maybe until to the level of real-time processing. Again, another improvement is to have a deeper network. To achieve deeper network, instead of adding set of up projection and down projections to more set of up projection and down projections, we can use transition layer. The last up projection layer can be used as transition layer. So the last input from down projection will be feed back to the first up projections, and then we will have some iterations between up and down projections to produce additional high resolutions feature maps, and then we can concatenate all the high resolution feature maps finally, as we did in the initial network, to to produce the real high resolution images. So the last improvement is actually can be done for image enhancement and image denoising. In super resolutions, we do care to increase the resolutions of the image, while in image enhancement and denoising, we don't have to increase the resolutions. What we can do is actually very simple. By using the opposite order, instead of using up projection first, we can use down projection first, then using up projections again to bring the low resolution features back to the original resolutions. And then we have set of down projection and up projections, and then we can do the same using the last layer as transition layer, or even as in the initial network, we don't have to use it as transition layer. Then finally, we have set of high resolution feature maps. We can concatenate all of them and then produce the enhanced version of input. Here, the intuition is the down projection will reduce the noise from the input. So let's say if we have a noisy input, by downscaling this in the image, we will reduce the noise. And then that's the intuitions. Using the downscaling process, we can reduce the noise, number of noise exists in the image. And then we enlarge again the image, and then downscale again, upscale again, downscale again. And then this iterative will have, we understand the up and down downscale operators, which can enhance the input image. Here's one sample. The left is the input and the right is the output. We can see that it is clearly the right is enhanced much better than the left, which is the input. Let us go to the second topic, which is video super resolutions. Again, I want to introduce our paper here, published at CVPR 2008-19, called Recurrent Back Projection Network for Video Super Resolutions. This paper also won several challenges in 2019 in video super resolutions and also video deblurring. So this is the related works. The existing deep video super resolutions I categorize into three categories. First is temporal concatenations. The input image is concatenated and then it is fed to the network. But there is some limitation, of course. For the first category, it fails to represent multiple motion regimes between each context, since all the input image is just concatenated without any separations. B, temporal aggregations is actually the extension of A. They use multi temporal scale. For example, here first they feed only one single images, and then they use additional two contexts, and also they use in the third they use n contexts, and then finally they combine all these ensemble results to produce the real high resolution images. But again, like A, it will be difficult for the network to optimize the multi-scale in the globally. In C, they use recurrent neural network (RNN). The input will be fed to the network one by one until the last step. They will produce the high resolution images. But again, it is hard to model subtle and significant changes between each context, since all the input image only works in one axis. This is our proposal. We call it recurrent back projection network, RBPN, different with the existing network, which is only works on one axis, which is the horizontal axis. We add another vertical axis. So there is two input in our methods. In summary, there are two contributions for our paper. One is we combine single image resolutions, which is present from the horizontal axis, and also the multiple image resolutions, the combination from vertical axis, red arrows, by extracting the missing details from different source, then we iteratively update it in temporal order through RNN for video resolutions. We can improve the performance of we can improve the results of the images. Here, since we separate the context IT-1 with IT and also IT-2 with IT, which means that the network will treat each context as different queues, and then it will allow RBPN to separately capture the degree of change for each context. Then it will perform back projections for each context to iteratively improve the IT to produce, then finally to produce the SRT. So as illustrations, let's say we have frame A. Frame A will be enlarged by using some single image resolution methods, but it still have blurry effect here. Then using the context, for example, frame B, we can see the difference with frame A, and then we can apply the details to the target image. Also, we can apply again to another context to improve the image, and also we can see again to see what is the difference between these frames and the target frames, and then we can apply it until we have better results compared to only rely on one single images. Here's what happened inside projection modules. I might not want to go into the details, but basically inside the projection modules we have again back projection mechanism. Here we calculate the difference between the multiple image resolutions and the single image resolutions, produce different HL and HM. We calculate the error reconstruction to produce the refined high resolution feature maps, and the decoder itself only used to bring back the high resolution feature maps back to the low resolution feature maps. Here's some ablation studies showing that adding the context, let's say using 2 frames, 3 frames, 4 frames, 5 frames until 6 frames as the context images, as context frames, we can improve the performance of the network. Here visually also we can see until 6 frames we can get the perfect results compared to the real ground truth. If we compare with the other methods, here PSR the UF, which is the CVPR previous year, we can outperform these methods, totally outperform these methods in several optical motions, in slow motions, medium motions, and then in the fast motions. Here I want to compare that this is the input image. We can focusly on see in the the changes in the red arrows. Input image, and then bicubic still not really improve the images. Using VSR-DUF, which is the previous methods, it can improve but not that clear. But using our methods, we can clearly improve the pattern of the bricks. You can see it's very sharp and clear. It also happened in the second images. Let's say if we want to detect the character in the card, using only the input image, we hardly to read what is the character. Using bicubic, it is clearer but not that easy to understand what is the character. And using VSR-DUF, it's not helping, actually. It's somehow sharper, but not helps us to understand the character. But using ours, it's totally much sharper, and we can understand what is the character means. It's Zabita 153. So finally, we go to the last topic, space-time super resolutions. What is space-time super resolutions? Maybe some of us is not quite familiar with this term. Space-time super resolution is actually increasing spatial resolutions of video and also simultaneously interpolating frames to increase the frame rate. So in this case, if we have small video with a low frame rate, we can produce higher resolution video with the higher frame rate as well. So our paper called Space-Time Aware Multi-Resolution Video Enhancements, or STAR, will be published at CVPR 2020. The code of this paper also available in the internet, in the GitHub. You can try it by yourself if you are interested. So again, first, the related works, how to perform space-time super resolutions in the current methods. I want to firstly introduce A and B, which is maybe quite familiar we see from the previous presentations. A, if we want to perform video super resolutions, we basically want to improve the resolution only, the resolution of the input frames to the higher resolutions. While B, video interpolations, we do care to increase the frame rate. So for example, if we have LT and LT plus 1, we want to interpolate the middle frames, the in-between frames between T and T plus 1, which here we present as T plus N. N should be any number between T until 1. So for example, 0.5. So to perform space-time super resolutions, we can use the combinations of A and B. Like C, we first perform time and then space resolutions. First, we perform the step 1, we perform video interpolations, TSR, resulting LT plus 1, and then we enlarge the image one by one, the frames one by one, using video super resolutions. Or the opposite, we have set of low resolution frames. First, we improve the resolutions to higher resolution images in D, and then in the higher resolutions level, in the higher resolutions, we perform TSR, interpolating the middle frames in higher resolutions images to produce HT plus 1. In contrast, our proposed model called STAR, it can super resolve jointly in space and time. This joint learning on multi-scale features able to directly connect multiple resolutions, and these multiple resolutions can enable the network to estimate both large and subtle motions observed in the video. So for example, if we have small image, a large motion will be downscale again as we downscale the image, and also the opposite. When we have small motions in higher resolutions, we can see it clearly since the motion also enhanced to the higher degree of motions. So these two multiple resolutions will enable the network to understand both large and subtle motions that is observed in the input image. So we come up with these architectures. The input is two frames, two low resolution frames, but and then also the bidirectional dense motion from maps f from t to t+1 and also t+1 to t, and simultaneously the output is the 3 frames, which is the enlarged frames ISRT, ISRT+1, and also ISRT+n. And also we produce another low resolution image, which is the in-between frames between ILT and ILT+1. We produce ILT+n. We did several ablation studies here. Let's say what happen if we only have STSR module, which is present by the purple arrows. It's present as the first method, and the second method, what happens if we add another connection from the higher resolutions, not relies only on the space-time super resolutions arrows, the purple arrows, we add the blue arrows as well in the higher resolutions. Also, we compare what if we only relies on the low resolutions arrows here, adding the purple arrows. And also the final comparison is we use the full setup. All the arrows from low resolution and high resolutions, also the connection between low and high resolutions is connected. We see in the table below here the first, second, third, and the fourth is improve each other. Finally, the fourth, the full setup, has the best performance among others. We can see that only using STSR is outperformed by the second options, and also it shows that using the third option is better than the second options, although it is small difference actually. But again, the full setup is outperform all the combinations, all the other setups. And I want to say also that star can be fine-tuned to specific tasks. For example, if we see star can produce 4 outputs. Star can produce 4 outputs, 3 high resolution frames, and also 1 low resolution frames, which is in between frames between LT and LT+1. But we can also train the network to care only the space-time super resolution output. So basically, we only want to produce high resolution pictures with higher frame rates only, which we call star ST. So in this case, we only optimize on 3 frames. And also the third options, we can also care what if we want to perform star to perform video super resolutions. So we only train the network to care only on the 2 frames, which is the enlarged from the input images, the input frames. And then also the last, we call it star T. Instead of increasing the resolutions, what if we only care how to increase the frame rate of the input, which resulting we only produce the LT+1. Here some interesting results. We can see that by fine-tune the star to specific tasks, we can improve the performances of star. We can see in global, star produce all the inputs, all the outputs. We can see it's relatively quite good performance. But if we care only space-time inputs, space-time outputs, we can use star ST, which is outperform star. And also, if we do care only on the video super resolutions output, which is ISRT, without increasing the frame rate. We can use star S, which also outperform star ST and star. And also same happen in star T, although it's not quite big difference between star, but we can also improve the performance by using star T to only perform video interpolations. We also want to show that our network is successfully to refine the flow informations in the network. We can see that in the left side is the input images, the output results, and the input flow informations. In the middle is the output using the refined flow information by using our network. We can see that it is improve the quality of the flow informations by using our network. Also the same happen in the image 2. The left image is only using the raw flow computations, while in the middle we use our flow refinement modules, successfully improve the flow informations, which is relatively the same with the ground truth flow informations. To compare with the state-of-the-art methods, we can see our star successfully outperform other methods on all tasks. Space-time super resolutions only, space super resolutions, or time super resolutions, which is video interpolations. So here we can see the combination of other methods to perform space-time super resolutions is outperformed by our model. Both if we only rely on star, it is quite comparative with the previous methods, but if we fine-tune the models to star ST, we can outperform other methods. The same situation also happen in SSR. We can see that S star ST and star S can outperform previous methods, and also TSR, we can see star T can outperform the previous methods. Here's some sample of video results. We can see that star produced sharp and better video close to the ground truth. Here again, if we see frame by frame, this is the first frame, the second frame, we can see that it can improve compared to ours have better interpolation compared to another methods. Here, if we see the last row, we can see that the lag of this player is gone in other results, while in our method we can see that these subtle motions between the changes between the legs of this player still exist in our results. Okay, that's all for my presentations. We can continue the discussions in the live Q&A. Thank you very much for your attention.
Okay, thank you very much for Dr. Haris for recorded video presentation. So now it's time to us to have the live Q&A. So the live Q&A will be maximum 40 minutes. So if all the attendants want to ask something to the Dr. Haris. Hello, Dr. Haris. This is the first time to see you.
Yeah, nice to see you too.
Okay. Okay. Wait, I will read the question for you.
So we already have questions.
Okay. Maybe while we're waiting for the question from the audience, okay, I have one question. Okay, one question. Sorry, we have two questions from the same audience. So the first one, how does your model check the quality of the superpixel resolution output? So that one will be the first question. And then, is there any ground truth involved during the training stage? Did you try your model for a completely different sample, or maybe you use the same sample? And then the second question is the resulting super resolution output influential or maybe impactful to further research? Something like that. Okay.
Okay. Thank you for the questions. The first questions related to how we evaluate the results actually. So the common objective functions currently. So commonly there are two evaluation methods in super resolutions. First, the objective functions. Usually people use like PSNR, peak signal noise to ratio, and or like root mean square error. But these objective functions, it has been found that it's not really represent how the image itself is it visually good or not. But because PSNR and RMSE tends to like over smooth the image. So let's say, for example, if the network optimized by root mean square error functions for super resolution tasks, the output of the image will be smoothly. Like we cannot see the pattern, we cannot see the details of, for example, the texture of the bricks or the sand or something like that, because of the over smoothing. The second, that's why if I want to share the detailed scenario, there is also another method. Might be familiar with GAN, generative adversarial network. We can combine the super resolution network with to optimize the super resolution using GAN architectures. So therefore, we can also combine the objective functions, not only relies on root mean square error, for example, but also distinguish the loss from discriminator using the GAN architectures to identify, is it the representation of the output super resolution, is it the same with the real image representations. So that's one approach. The second approach is manually annotated. Like we can test to several human. So some human will give some scores, which image is better by scale, like let's say 1 to 10, and then they will give some specific specific points for each image, and that's called subjective evaluations. But it's time consuming also, of course, because it involves a human. And the third, there is also a third evaluation actually, which is incorporating super resolutions with another task. For example, another computer vision task, like image segmentations or object detections. For example, let's say we have small image, we enlarge the image, super resolved image. Then this super resolved image is the input of the next task. For example, as I said, segmentations. And we can compare the accuracy of our resolved images compared to the initial input, real low resolution images. So basically that's three approach maybe which is commonly used right now in super resolution fields. And there's another following question related to ground truth. I think for super resolutions also there is two approach. supervised learning, which is mostly these three topics that I mentioned here, basically based on supervised learning. But also there is a self-supervised approach. There is some papers also related works in these fields, like zero-shot super resolution. So basically what they are tackled is what if the downscaling operator in the let's call in the supervised learning, we already have set of low resolution and high resolutions images, and usually the how to generate this pair of training images, we downscale from high resolutions to low resolutions. Basically, so it means we can have any image as high resolutions, and then we can simply downscale using several downscaling operators, and then we have set of training pairs, low resolution and high resolutions. But the second approach for self-supervised or unsupervised learning, the argument is, of course, we cannot always know what is the downscaling parameters. For example, like the noise exists in the downscaling, during the downscaling and everything related to the domain difference. So the approach is quite different. One, they are also proposing, while doing the training, like simultaneously doing training and inference by one stage. So I might unable to explain it in details, but that's what is the main idea of the unsupervised learning for super resolutions.
So it means that it is possible for us to make the image resolution without ground truth, right?
Yes. That is also
okay.
possible. Yeah.
Okay. How about the
second questions? Can you repeat, Pak?
Okay, the second question actually related to the result of the super resolution can be affected the result or maybe the performance of the object detection or maybe another computer application task, computer vision task. Okay.
I see. Yeah. I mentioned also in the first questions actually, and I did several research on this as well. Like it is very common that scale problem will reflect to the performance of any computer vision task, like object detections. If the image is low resolutions or the object is small, the current methods will fail to identify the objects. Therefore, I've also forgot to mention this in the PowerPoint actually. Therefore, the current trends actually for super resolutions not going to the performance solely based on super resolutions, but also integrating with other computer vision tasks. For example, as I mentioned, image segmentation or object detections. And intuitively, it's well correlated, but thanks due to a deep learning era currently, the joint learning can be done easily. So basically, in simple way, we can just connect two network, which is like, for example, super resolution network and also some computer vision task network, jointly training, and both network will optimize by both laws. It means both network will cooperating and identifying the object detection network, for example, will give some semantic informations from their loss, and also the same from image resolutions. They will try to see what is the pattern that are seen by the object detection network by giving their loss to the object detection network. So the answer is yes, and even the current approach, the current trends of super resolution going to that directions to jointly optimize both tasks. And also in the last topic, like I tried to jointly optimize both space and time super resolutions, and many other previous work as well, showing that this mutual connection can help the tasks to improve their performance. Yeah.
Okay. Okay. I will remind the audience, if you have any question to the Dr. Haris, please type in the question channel. Okay. Before you mentioned that the super resolution output can also improve the result of the computer vision task, right? Yeah, but maybe we know that in contrast, if we want to process the image, we also consider about the processing time, because if we have very high resolution image, so the processing time when we apply for computer vision task will be very slow. But mostly the researcher, they try to reduce the resolution and then they do analyze. So what do you think about this one, about the processing time?
Yeah, that's interesting actually. Just recently, I saw one image. The sample that I mentioned, simply connecting super resolution network with any computer vision task. Of course, as Pak Wahyono mentioned, it will burden the computational time. But there is another related works. They not utilize the super resolution network on inference. So basically, during training, the network try to integrating the informations. I think it's called like dual network. For like the objective is for semantic segmentation. So their intuition is, if we have larger features representations, we will take benefit from that. So instead of separating the network, they combine both network, semantic segmentations, and super resolutions network. But during training, they utilize the high resolution representations. But during inference, since they have some mechanism during training to understand higher representations, but during inference, this super resolution network itself, it's not necessary anymore. So mainly they will only the super resolution network just use during training. So during the inference, it will not burden the computational time. So basically, it's still the same, remain the same. So there's one possible approach, of course, and maybe we can explore more on this because it's still, I think, not so many papers working on these fields, as Pak Wahyono mentions, because basically current trends, they downscale the features to give general context, more bigger context to the features. But there is also, as I mentioned, if it contains, for example, motions which is subtle motions, once we downscale the features, of course the subtle motion will be decreased again to even lower magnitude. This approach might works for like high motion estimations, or maybe normal motion estimations, but small motion estimations, for example, if we want to relate it to the smart vehicle, like object detections with very far object, the gestures of the pedestrians will contains very small amount of motions. If we downscale again by doing segmentation, for example, those motion will disappear totally. That's why doing computation in both resolutions, high and low resolutions, is one of the trend currently. Actually, there is also another paper doing like they keep both representations on high resolution and low resolution for, I think, for object detection tasks. And it also shows it can give improvement to the performance of the specific task.
Okay. So how about the processing time for each image when we want to enlarge? So from the small image become the big image in one frame. How long the processing time usually we can take in the testing stage?
It really depends on, for example, DBPN. For the first topic, the first topic, the input is single image, and the output also one single image, high resolution. Based on my experience, let's say, but I never try using CPU. Solely based on GPU.
Always GPU. Yeah.
GPU. In this case,
because in Indonesia it's quite difficult to get the GPU. Usually we use the CPU. Okay, and because this is related with the next question is about the processing time. If we want to implement maybe DBPM or maybe another method that you already proposed, so this is possible to implement them in the low resort device, such as in mobile device or maybe in Raspberry Pi and something like that.
For specifically for the first topic, actually, I mentioned in the PowerPoint in the presentations that there is some room for improvement for the real-time applications by using. So the trade-off is, of course, using shallow network will decrease the performance.
Yeah.
But the trade-off, as Paulian also mentions, since the limitation is we don't have that high computational power, for example, one strategy is decreasing the depth itself. Let's say the up projection and down projections. Based on my experiment, using only one cycle, one up projection and one down projection, even it still works to super resolve the image better than, let's say, bicubic, for example. Using only one up projection and down projection modules, it means roughly the depth of the layer maybe around 10, I think around 10 possibly. And I think 10 is still reasonably will perform quite well in CPU. Then another approach, of course, we can do. There is many papers related to how to optimize the network, like adding the kernel 1x1, separating like instead of using directly 7x7 kernels, we can separating to 2 different kernels using basically the same output, get the same output. That's kind of modification is still possible for the current network because I haven't did that optimizations. Yeah, I think that one of possibility to do. But for the second and the third topics, I'm not quite sure for real-time applications because it's quite heavy tasks and specifically to the third topics, basically we do simultaneously 2 tasks, not only increasing the resolution but also increasing the frame rate.
Okay. So for the first task, this is possible for us to implement in the mobile device, right? And then, but for the second and the third one, I think we need to improve. Maybe this is the future research for us, maybe for you also, for us also, because currently in Indonesia we have problem with the computational resource, right? So mostly we use the CPU, or maybe we can just use the mobile device. And how about as I inspect in the your PPT, so mostly the input is using CCD camera, the CCD camera. What happen if we use the omnidirectional camera or maybe fish eye? because in the omnidirectional camera or maybe the fisheye, the image has a lot of distortion, right? So is it possible also to increase the resolution?
Yeah, that's also one of questions. Why the background? Why unsupervised super resolution is needed? So as you mentioned, for supervised learning, basically in the super resolution research, they just mainly downscale the high resolutions. The assumption is they have high resolution image and then they just downscaling it. But it will not be the same with the examples as you mentioned. That's why another approach as well. It's not slowly. I mean, we cannot really rely on super resolution tasks, but in the same time, one of possible approach is combining these super resolution tasks with like deblurring methods or some denoising methods, which will give more semantic information to the super resolutions about the noise representations during in the input images, for example, or if we working on the video, there's some blur effect, for example, in the video. Then that's also one of possible approach. Another approach is we can simulate all, even this, but still I'm not really agree on this approach actually. Some of papers like simulate all the possibility noise that are exist in the current videos. For example, not only based on solely based on Gaussian or some artificial videos, but they collect from many device, for example, like DSLR camera or even some infrared camera or any type of images. But again, of course, we can argue if there is another new new type of image, it will not solve this problem. That's why the best approach currently for supervised unsupervised learning super resolutions, using predefined networks super resolutions, we can fine tune. There is another stage which fine tune the output of the network to the specific domain. So it's like combination of domain adaptations to the super resolution task. So that's one of the best solutions currently I saw in the current trend. Yeah, that's maybe but.
Okay, and I will check. Okay, I think this one will be the last question from the audience. But if the audience want to ask one more question, maybe you can just write in the question panel. So the next question is, this is coming from the organizer, from the audience. So what kind of the innovation do you see in the future about the image processing and image enhancement for utilizing the image supervision trend?
So as I mentioned, it's the image enhancement fields itself. It's quite fundamental, but still.
Halo? Halo? Halo Pak Haris?
Of the current situations. That's for movie industry. Basically, the use case is very simple. Let's say they have old video from the films or some old camera, and then basically they want to display this video to current monitor, which is 4K display or even higher, high HD, even higher 8K video. Sorry, I think I lost my connections. Hello?
Hello, yes, I can hear you.
Okay. Okay, Pak. So that's related to the movie. And another possibility also, as I mentioned, in how to give more detailed representation, for example, integrating these super resolutions to the specific task of computer visions. Now I haven't saw a lot of research on this, but current trend it's showing some researchers already start looking at this joint optimizing, how higher resolutions can give better performance, can give better representations to the some tasks of computer visions. There is also another interesting topic. Actually, recently, I might want to highlight this as well. One of researchers also talking about the bias that exists in the super resolution task. For example, if we have small images of a person, the network solely for supervised learning, the network will enlarge this image based on the training data that are given during the training. This bias will appear if most of the training data, for example, we use is, let's say, related to all is white people, like for example, and the input is the image itself is, let's say, the like us, which have quite not that white, sawo matang, maybe we can say, and the result of the output image is not satisfying because the network will force the output looks like the one we have white skins or something. That also one of the bias that needs to be solved related to the data set. But related to the task itself, as I mentioned, the large intuitions should be any the intuition is any of computer vision tasks. If we have higher representation, for example, motions or features representations, by and large, these features, there must be more detailed information that we can extract from these feature maps, for example. So integrating super resolutions will improve the performance, although there's some challenge, as Pak Wayon also mentions, about the computational time, the effectiveness of this enlargement procedure. Is it the trade-off? How is the trade-off compared to the performance improvement, and so on, I think. Yeah.
Okay. I think we have one. I think this is really last question. Okay, this is really last question from the audience. So I believe that in your proposed method, it is important in security system, for security system. For example, if we want to recognize a wanted person in public space, usually we need to enlarge the face, something like that. How is the limitation of your method? For example, this is effective or not if if the camera is zooming in X time. So for example, we zoom the camera in X time in order to capture the face, and then we apply the image resolution. So this is effective or not? Something like that.
Maybe some of us remember the PowerPoint I mentioned. I think in the second topics I saw the small car, like golf car, I think, showing the character. If we see just the input, relies on the input image. So it's like a detective movie, I think, like zooming the car numbers from the CCTV or some from the some small video. So we can see that our methods can improve the representations. We can understand what is written in the card. So basically, yes. So the answer is basically yes. One of the application is for surveillance, to give better details about the objects, for example, face or some characters, or any others which related to the scale. But again, since the supervised learning really relies on the pairs of training data, low resolution and high resolutions. It's still a big question for CCTV, for example, how to get high resolution image from those CCTV. If we treat CCTV as low resolutions, then how we can get high resolution of it? One of possible approach is we need to train. We need to combine. For example, we have a CCTV camera, and let's add another, for example, DSLR camera. Then we can have pairs of low resolutions represent from CCTV, and the high resolutions represented from DSLR camera. That's one approach. Then we can capture each image together simultaneously. Then we can generate pairs of low resolutions, real low resolutions, and then high resolutions. That's one of the tweak for engineering to generate this pairs of low resolution and high resolution, I think, if we want to still keep on track using supervised learning. And actually, this approach was used in the current mobile industry. So they have, for example, they map the input image, for example, from phone, solely based on phone camera, and then they have also DSLR camera, which give more dynamic range and information of the details in the image, and then they will produce these pairs of image, low resolution and high resolutions. Then they just apply the models to the mobiles. That's one of possible.
Okay, well, that one is really hard question to answer. So this is another question from different audience. So this is related with the ethical bias issues. So for example, if you see in the Google Map or maybe in Google Earth, some face is blurred. So I mean we cannot see the face because related with the ethical bias issue. So some company in USA, even they cancel the cooperation with police department because related with the ethical bias issue. So what do you think about this challenge for image resolution?
Yeah, it does exist in the current trends because of the dataset bias. And this kind of discussion is actually not really popular in other countries except America, except US actually.
Yeah.
where the privacy is really
important.
High priority, and it's not important for them.
In Indonesia, not Indonesia is we don't have the privacy.
Specifically not.
Yeah,
Yeah, exactly. but yes, I think this kind of problem is not only happen in super resolution fields, but also in some other fields. It's hard to answer for these questions actually. Yeah, basically relate to the data sets. The formal way, of course, we need to we need permission from the objects. For example, in this case, if it is human, we need the permission from the person, or the scenery from owned by some person also. But for computer vision, specifically to super resolutions, how to say, not only it does really matters if we want to enlarge face actually, but super resolutions not only face in this case. I think even if there is some specific, I have thought about this. If we train the network to some certain high resolution image, which specifically we give some blur effect to the face, automatically the network, of course, will understand that the face itself is not really important in this case. For example, let's connect this kind of problems with image in painting. For example, image in painting, like we feel the pattern that are, for example, gone in some specific image, but we can also do the opposite way. So instead of feeling the black box, the network also can learn the opposite way. Instead of face, let's enlarge the image. Only avoid the image that have faces. So in that case, of course, there is need some further research on this, but I think it might be possible to do this kind of training set. So basically, the high resolutions will not enlarge specific to the face, but only like the gestures, the scenery, or the cars, or the details of the character, or other components, other objects that are exist in the video or images.
Okay, I think I will check one more time. Oh, okay, because we have no more questions, so I think we can close this session. So before I close the session, let me conclude the tutorial session. Maybe you want to tell for the closing conclusion for your talk before I close the session.
Yeah, maybe one of takeaway points for these sessions is we can focus, as I mentioned, we need to analyze how important is higher representations, and how we can improve the performance of the computer vision tasks instead of solely like evaluating the super resolutions based on the objective functions like PSNR or root mean square error. But by integrating to another computer vision task, we can see the more task-driven objective, like how super resolution can improve the performance, how the presentation will give better information to the network, and so on. I think that's might be the best current trend that are happening in resolutions or video super resolutions, or in general image enhancement or video enhancement. I think, yeah, that's all from me, Pak. And maybe I want to say thank you for the invitation for these sessions. Hopefully we can meet face to face. Yeah, that's all I think. Thank you very much.
Thank you very much for Dr. Haris. So before I close the session, let us take a photo session. Yeah. First, okay, photo session between, yeah. Okay, smile. Don't forget to smile. Finish. Okay, I think finish. Okay. Okay, the summary from this talk for me is the first one is the image video supervision is currently growing and progressing, and in many computer vision application, usually the utilization of image resolution takes an important part in improving the accuracy, right? And low resolution image tend to achieve less accuracy than the high one, but in contrast, usually the high resolution require a lot computational cost. So this is the summary for me. Thank you very much for Dr. Haris. Thank you very much for the audience. So if you have any question related with this tutorial, you can ask directly to the Dr. Haris by email. So how we can get your email, Dr. Haris?
Yeah. Gmail may be better, I think. I will mention MU. Yeah.
MU.
I think it's also, yeah, muha.halis. muha.haris@gmail.com.
Okay, muha.haris. Or maybe you can just search in Google Muhammad Haris. I think he is very well known researcher, usually in the image. Okay, I think that's all from me. Thank you very much for your attention, and thank you, Dr. Haris, and thank you very much for the audience. And I'm really sorry that if I made mistake during this session. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak.
recognition and classification tasks. So in this work, we propose a deep learning algorithm to recognize one of the widely used hand gesture language, the American Sign Language. The proposed method implements a simple deep learning system called CNN-HOG. So we use a convolutional neural network to train a set of filters. The trained filters are then used to perform convolution operation with the input image in the layer of patch mean removal and convolution. Histogram of oriented gradient is then used to extract feature from the output of the layer of patch mean removal and convolution. The extracted features from the multiple filter images are then concatenated to form a single feature vector. Euclidean distance is then used to classify the test images. So this figure illustrates the architecture of the proposed convolutional network used to train the filters and a visualization of the trained filters. The filter convolve with the input image and produce a feature map that corresponds to the feature learned from the image. The filter weights in the convolutional layer are updated through backpropagation by computing the gradients and propagating backward through the layers in the convolutional network. The backpropagation mechanism allows the filter to progressively learn more useful features in each convolution process. We did comparison with existing methods including convolutional network, histogram of oriented gradient with artificial neural network, and principal component analysis with k-nearest neighbors on several hand gesture datasets. From the table, we can see that the proposed CNN-HOG outperformed the existing methods in all benchmark datasets. So this is another of our hand gesture recognition work. The previous one is working on a static image, but for this one, we are working on the video. In general, a sign gesture is recognized based on how the hands are moved, along with the changes of the hand shape from beginning to the end of a sign. For that reason, we propose an isolated sign language recognition method as depicted in the figure. Given a sign gesture, particle filter is proposed as a hand tracking mechanism to detect the hand in each frame. Particle filter uses the dynamic model and observational model to track the hand. The hand location and velocity is modeled in the dynamic model of particle filter, whereas a combination of pre-trained hand model by convolutional network and head motion information are considered in the observational model. In this way, motion information is utilized to detect the motion region. Then the presence of the hand in this motion region are further confirmed by the pre-trained hand model of convolutional neural network. Using particle filter, the hand tracking is performed by sampling the tracking candidate states. The candidate states contain information related to the hand location. And based on this parameter, the corresponding image patch is extracted. The image patches are then fed into the observational model of the particle filter, which calculates the joint likelihood based on hand motion and the convolutional network pre-trained hand model. The target hand is then determined by selecting the highest estimate likelihood of particle filter candidate. After the hand are tracked, the hand energy image is proposed as a compact hand representation to characterize the change of hand shape within the sign gesture. These tables show the quantitative performance comparison of the proposed method with several existing methods on the RWTH Boston 50 hand gesture dataset. The proposed method is the last column with the lowest COL error for most of the sign gesture. And this is the COL error result for the SLLVD dataset. The following slide shows the qualitative result for the proposed method on the selected sign gesture sequences. So those are our works on leveraging deep learning on video analytics. In real world, video analytics has been widely applied in many areas, such as retail analytics, industrial inspection, parking management, traffic management, visitor counting, post estimation, autonomous driving, and many more. This is my last slide. I hope this tutorial gives you a sense of what is deep learning and what is video analytics, and hope that it may inspire you to use deep learning and video analytics in your works, or to build something that is beneficial to the society. Thank you.
Okay, thank you very much for nice presentation. So it's very interesting because the presentation explained about the basic principle of deep learning and how the method implement to in the topic of video analytics. And of course, there are several examples that make easier for us to understand. Thank you very much. So while we wait for question from attendee, I think we will discuss several things regarding the topic. So as we know that we are in the COVID-19 outbreak period, and of course it's interesting to consider how deep learning in the topic of video analytics can be used in order to prevent the spreading of the COVID-19. Can you give any opinion or consideration regarding to the implementation of deep learning for COVID-19 prevention?
Okay, thank you, Dr. Isman. That is an interesting idea. Recently I have seen some work using the deep learning and apply to help the COVID-19. And one of the work is using the deep learning and the train a model to, for example, to detect the pedestrian. Okay, to detect the pedestrian, and they measure from the video. They measure the distance between the pedestrian. It is for social distancing detection. So to make sure that all the people are within the safe social distancing. And then the other work that I have seen is to a simple one using a deep learning to they first detect the face of the human, and then they detect whether that person is wearing a mask or not. Okay, to wear one is to wear the mask, and the other one is to wear the protector. Okay, there is a second work that I have seen recently, and then the third one is the one that I've seen is in the more on the medical imaging, where they use a deep learning train a model to help the doctor diagnosis on the lung X-ray images, so that they actually give a quite high recognition rate, and they help the doctor to diagnose the patient lungs. So these are some of the works that some of the researchers apply the deep learning in computer vision that help the COVID-19. Yeah.
Thank you. I think the fourth and second idea is very interesting. So have you tried to implement or develop that kind of system, for example, to detect physical distancing or social distancing? So for example, in one area, if the person is too close, it will maybe any warning or such like that. So have you implement?
I'm currently supervising a few students doing on this project.
Oh, okay. Okay, we still wait for the question. So, okay, we have a question from. Okay, we have a question from Mr. Chandewan. The question is, how far are deep learning with video detecting implement in your country? So how far are deep learning? How far are deep learning with video detecting implemented in your country? Or maybe in the real implementation in your country?
Real implementation in my country.
Yes.
Some of the work that I presented in the video, for example, the object detection, that is actually a work that we collaborate with a local company to help the to use the AI feature to help the advertising company, okay, to select the most suitable advertisement to display on the digital billboard. And then and another work is that I present is the video surveillance one. That is also a collaboration with a local company. They want to develop they want to enhance the CCTV and integrate with some AI feature so that they don't use a sensor, use a computer vision technique to detect the intruder. Okay. So so from this collaboration, I can say that in recent year, not 10 years ago, but in recent year, there are quite many AI startup companies that use the deep learning and apply it to solve some of the problem in society. Yeah.
Thank you very much. Okay. Actually, I still have another question while we wait for the question from attendee. So regarding the implementation of deep learning, especially for computer vision, I think it should be in parallel with the increasing of the computational resource, right? Computational resource. So because we need to have proper computational specification to can run the deep learning. So do you have any suggestion? For example, may we have implement deep learning with the limited computational resource? Is it still possible?
Okay. Okay, for this question, it depends on the application that you want to implement. If it is a small scale one, like the maybe just static images, and then the data set is not too huge, then you can use some online resource like from the Google Colab, okay, Google Collaboratory. There are free version of that. You can use it. And then, but if your application is involved with huge data, especially in video analytics, you have several 10,000 or several 100,000 of video to process, then you need quite a very quite good computing resource. You need quite recent GPU to process it. Otherwise, it will take very long time to just train one model. Okay. Yeah.
Okay. Okay, I have another question. Regarding the implementation of deep learning in video analytics, for example, especially the implementation in the public area. So is there any consideration about the privacy? So for example, as we know, for example, in the billboard ideas, we install several CCTV, and of course it will record object in the public area. So what kind of consideration regarding the privacy?
Yes, thank you for the question. This is a good question. When we collaborate with the company, for example, just now the advertising system, we actually discussed on this issue. But so far there is no laws imposed on this area yet. I'm not sure about Indonesia, but in Malaysia not yet. And then US also previously they are using the face recognition system. Just recently, some of the giant companies they stopped the face recognition services in US. But in other countries, so far I haven't hear any country that impose this kind of law to stop any system to use a face recognition. Yeah. So far, I think that so far there is no privacy issue on this one, because when we implement this, we actually capture the face, but we don't store the face of that person. We are just extract the feature from the face of the person, and when we pass the feature to the deep neural network, and train it to get the best suitable advertisement. We don't store any feature value. We just want to display the advertisement. So we actually don't store the we actually don't store any privacy feature from the person itself. Yeah. So I think should be no privacy issue in this case.
Thank you. Because I see a video in one city in China that there is many CCTV and the resident is very the privacy is very low. So
Yes.
for example, the government can monitor a person from in a week, so they know a very detail about one person, and it's I think it's little bit break the privacy law maybe.
Yeah.
Okay.
Yeah, it's applicable in China.
Okay. Actually, we have another question, but it's still. I think you have answered about the privacy, so we will still wait for another question. So I will ask another topic. So for the beginner that have interest in deep learning in video analytics, what is the entry point that can you suggest? Entry point for to learn. Yes.
Okay. I'm a lecturer teaching AI in FISD MMU. So entry point for deep learning, I would say that first you need to learn some of the basic machine learning, the fundamental of the machine learning first, and then maybe learn pick up a programming language on this one, maybe Python. It can be Python, C++ or Java, but so far Python is the most popular one. So and many library has been developed, so it's very easy to pick up. So I would suggest you to learn Python and then pick one machine learning course, fundamental machine learning course, and then from there slowly you can go into the deep learning. There are many free courses online. You can get it from Coursera, Udacity, or Udemy. There are many.
Thank you. Have you developed your own library for Python? I'm sorry. For example, for have you developed your own library for Python? So maybe other can use your library.
We do develop our own small library, right? But we don't release it to public for some of the for our convenience to develop our own network. Yeah.
I see. I see. Okay. Okay. We still wait for the question. So, I will ask another question. So regarding the object tracking, actually I interest in object tracking. So for example, I don't know. I have seen a video about a drone that can follow the object. So maybe it's used the object tracking, right?
Yes. 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 The drone equipped with. Yeah.
Okay. So what's the impact of object speed? I mean, how the system in deep learning can still track the object with the certain speed. So is there any threshold in the speed? So for example, if the object move in the certain speed value, the system will fail to do a tracking.
Okay. Speed and performance is a trade-off in many cases, not just object tracking. It is same to all other tasks like object recognition or object detection. Yeah. So if we want mostly for real-time application like the one that you mentioned, using the drone to perform the object tracking, maybe they use it to apply to track the pedestrian or track maybe the sport activity. For this kind of real-time application, they need more real-time tracking result. So usually they will use a more so not so complex network. The network size will be smaller, and then which can achieve the tolerable performance, and they will apply that one to this kind of real-time application. But if you aim for higher performance, maybe with one very accurate recognition rate, then the network needs to be more complex, and you need to have a high more amount of training data to let it train a good model. So when you deploy the train model to the application, it also will take slightly longer time to process. So it's a trade-off.
Yes. Very nice. Okay, actually there's one question from Mr. Chandiawan, but in my opinion the question is still not clear. How can you secure your network?
Secure my network.
Secure, yes. I'm also not sure of the meaning of the question. Maybe you can guess the meaning.
I'm so not so sure about. I'm not fully understand about the question, but if you're talking about security in deep neural network, so far I have no experience in this, so I have no knowledge in this one. But in some of my colleagues, where they are doing research in security, they are trying to use some encryption algorithm, try to encrypt the network so that the train model doesn't disclose to the public, so that they can't use the reverse engineering and to review what is the network architecture of what is the train model of your train model. But the details I'm not too sure. Sorry about that.
Yeah. Okay. Thank you. Okay. We move to my question. So I'm interested with how deep learning can detect human behavior. So for example, I don't know the implementation has been exists or not, but can the system detect, for example, the CTF behavior? So for example, in any space, we can detect a person that high probability to rob or do the bad thing. Can you? So it's
Sorry
like
for
human behavior. So human behavior. So is it possible to make a system to detect a person that maybe do a bad things? So for rob or as a thief.
For human behavior, I actually supervise a few students. It's also video analytics. It's just recent one, but we haven't published the result yet. So one of the work is because I think last year Malaysia government, the Ministry of Health, they imposed a law that no people can smoke in the restaurant. So we actually develop a project to detect person who's smoking in the restaurant. So that is one anomaly detection in the video. Yeah. So when the person, we detect the person, and then when the person is smoking, then we will alert the owner of the restaurant. Yeah.
Okay.
We also train a deep neural network for that purpose.
Okay. Actually, there is also one question, but I'm also not sure the meaning of the question, so I will ask further to the attendee. So still, while we wait for the next question, we can move to another topics regarding the training process. So what kind of efforts that you perform to obtain or collect the training data? So for example, for object detection or human behavior. So of course, to develop a model, we have a valid training data. So is it public available, or you collect by yourself?
For some of the tasks like the object tracking that I presented just now, that is an online benchmark data set. Okay. And then for some of the collaboration with industry, like the advertising system for the object detection, and also the video surveillance. The data set is actually a collaboration with from both parties, from us and also the so industry provide us some of the data that they collected, and then we use the data to train the model and deploy the model for them. Yeah.
Oh, I see. I see. So because I guess it's quite difficult to collect the data because
Yes.
to have established model, we have many training data to represent the real case of situation.
Yes.
Okay. I will read the question, even I'm not sure the meaning of the question. There are many elements with monitor, so how do they manage the network from intruder?
Sorry.
Okay, I will ask further to the attendee about the question. Okay, while we wait for next question. So, in your opinion, what is the main challenge in this field
Main
for the
challenge
future?
For the future.
Yes.
Okay. If you're talking about the challenge in deep learning, is that as I mentioned in my video, what we need for deep learning to be success is one of the factor is a huge amount of data, so that we can train a good model based on this huge amount of training data. But the way that human learn to recognize an object or perform an action is not based on huge amount of data, right? When we see a new object and we are told that what is that object, we actually just take one picture of that object and we can already memorize, or we can already remember what is that object. It actually comes from very little sample. So so I think one of the main challenges is how we can allow the deep neural network to learn from maybe little training sample, like how human train our brain. Okay, so working on this, many of the deep learning pioneer researcher, they are working on this area in recent year. So I think started from last year. I also supervise 2 postgraduate students working on this area. We are exploring on the meta learning for feature learning, so that we can learn the use very little sample to train a good deep neural network model. Yeah, that is one of the big challenges. Yeah.
I hope we can overcome the challenge.
Yeah.
Okay. So regarding the running time, so of course it's depend on the case and number of data. But if you take the average, how long how long the time that you need to develop one model for the average?
For you mean for training?
Yes.
Or how long time it takes to train a model?
Yes. In average.
Okay.
In average.
In
average.
In average, okay. For all the works that I've done from me and also my partners, research partners, in average, so in average for video analytics, I mean for video analytics, for image it will be faster because the image is just static image, so it will be much faster. For video, one video is a sequence of image frames, okay, a sequence of image frames. So in one video there are many images, many images. So in average, the running time for us to train a model like the human action recognition that we have been done, it took us a few days using 2 GPU to train a model. Okay, a few days, 2 to 3 days to train the models. So we're actually using two GPUs, quite decent one, RTX 2080, okay, 2080. So I think it's one of the latest model with two GPU. We're running on the UCF 101 and HMDB 51 data set. We actually require two to 3 days to train the model. So if the model performance is not good, we need to repeat it again.
Yes, of course.
Yeah.
It's nice. Okay, so you have your own computer resource, right?
Yes, in our research lab, we actually, I think, in total, currently we have about 8 RTX 2080 for different projects.
Incredible. Incredible. Okay. Okay. So, can you give an opinion about how the implementation of deep learning in video analytics in the development of robotic, or have you implement your program for robotic field?
So far, no. So far, no. I'm more focusing on the, I mean, the software part compared to the hardware part. Yeah, we are most of my work focusing on train the model, and then we deploy the model for the system, like the advertising system or video surveillance system, and recently for object detection for some of the online shopping e-commerce system. Yeah, to help them detect the object
But
in
is
the
it
image.
feasible, right?
Yeah.
But is it feasible, right, to implement the analytics for robotics? Is it possible?
Yes, it is possible. There are many research in this field, but my focus is not in there, so I cannot comment anything.
I see. I see. Okay. Regarding the video surveillance, as you explained that in the COVID-19 period, we can use to detect one that's not wear mask. And how about temperature detection, combination with temperature detection? Is it feasible or not?
For you mean for the
human temperature detection?
Yes, it is possible. Yes, it is possible. Actually, there are people combine the face mask detection and also the protection detection together into one model. But for my side, I haven't working on that one yet. Yeah.
Oh, I see. Okay. Okay, we still wait. Maybe because the attendee should type the question, so it's a little bit delayed. So
okay.
We can discuss another things.
Sure.
Okay, regarding the object detection. So for example, if we have one criminal, and we submit to one database. So how fast the face of the criminal can be detected by the system? Is it need any retraining process or no?
You mean it depends on different cases. One is you already supply the network with the images of the criminal, okay? Maybe
yes.
the faces. Then what we need to do is just detect the faces and then do the matching. That can be quite fast.
I see. I see. Matching. It's the keyword.
And then for the like the cases that you mentioned just now, you have seen what China implemented. Yeah.
Yes,
actually
I see the video.
And then do the matching. That can be quite fast. And you see their system is almost real time. Yeah.
Yes.
And if the data of the criminal is not known, and then we need to slowly get the data and retrain the network, there is in recent year there's such field called the online learning. Online learning means that from
I see online learning. Yes.
We are supplying new data to the network and it keep learn on the new data. Yeah, keep training. that is quite
Yes,
a new.
Because yes, because I see the video. One person just register as a criminal, and he exit from the room, and in several minutes there any police catch him. It's very fast.
Yes, yes.
Very fast. The system detect the face of the person.
Yeah.
Okay. Very nice discussion. Because yeah, as we know, we can say that we have entered the deep learning era. So everything can be possible by deep learning. So of course, it's also included the field of video analytics. So I see in your slide that at least in video analytics can analyze the spatial and temporal. So we can, for example, detect the station or the contour of one area. So is it possible to disaster by using video analytics?
Sorry.
Is it possible to detect the probability of disaster? For example, earthquake or etc.
Disaster.
Or flooding.
Interesting question. Previously, there are some collaborator looking for to find a collaboration with me to doing some of the work, but most of their prior work is using the sensor, especially for disaster, for the flood, and also the fire. They are using mostly they are using the current technology. Most of the people they use the sensor, for example, the smoke or heat detector, or the water the water level detection sensor. So sensor their response rate is faster. At the current moment, but in recent year, many people are looking for a combination of information, not just from the sensor, but also from the computer vision. So I actually collaborate with one of my colleagues on fire detection. Where when a household is on fire, then we detect and we will automatically, the system will automatically inform the fireman. Yeah.
I see.
But for earthquake, I think using computer vision will be quite. I think maybe it's quite late. I think sensor at the current moment will be better. Yeah.
But if the earthquake occur gradually, maybe we can do any prevention and evacuation maybe. So regarding the implementation in the e-commerce, so you said before that your system has been implemented for billboard. So can you explain the activity of the implementation, the effectivity, for example, the increasing of sale or something like that? Maybe report from your partner.
For that project, the AI-based advertising system, the advertising company, they actually already have they actually have about 60,000 of billboard across the globe. Okay,
very good number.
Yes, big number. So we actually train on some online benchmark data set, and then we deploy it we deploy it to their advertising system for them to test it. But the result is not so good because the data set is from online and it is not for their cases. So then from an online data set, we actually achieve quite good result, quite good performance. So we retrain the model with the data that they supply to us from all the about 60,000 billboard. They install the camera and we get all the recorded video from them, and it took us quite some time to do the data labeling so that we can pass it into our deep neural network to train again with their network, with their data. So the difficulty is very time consuming for data labeling because from many camera, from many digital billboard, and for many video, very lengthy video. So it took us very, very long time.
It's very interesting. Okay, so I have another question. So if regarding your explanation, so you have so many products, and also as a researcher, we also have to write a publication, right? So what's your suggestion to balance between produce the product and write the publication? For example, in my opinion, in one side we have to develop a method to can publish in one journal, for example. But also we have to provide time to develop the implementation of the system. So how can you balance between the product and the academic publication?
How can I balance? Okay, interesting.
Sorry.
For most of the collaboration, so far for my case, for my own case, for most of the collaboration, we actually more focusing on the train the model, and then to deploy the model to the system. Actually, that part is in charge by the collaborator of the industry partner by themselves. So if we are focusing on the training the model, we are actually doing we actually still doing the research part. So any output which is confidential and used by the company, we'll keep it, and any output that we can publish, then we will publish it. That is what we do so far.
Oh, I see. Because I imagine that it will be difficult if we do both parts. So
yes.
I think it's nice if we have a collaborator. So we have a question from Mr. Chandiwan, same person. So there are many tools for monitoring that connect to the system. How do they maintain the security of those tools or elements from hacker? So it's maybe related to the security.
Security again. As I mentioned just now, I'm so sorry that I'm more focusing on the AI part. I'm not so sure how they can apply the security to the for the AI model. I have no experience on that one. Just now I already mentioned. So I think that is still quite a new field. Because so far I haven't seen much research on this one, on how we secure the model that we train, so that people is very difficult to do the reverse engineering on the output. Yeah. But I'm sorry that I'm not able to answer this question. I truly have no knowledge on security in AI. Yeah.
Yes. So it's interesting because if we learn more about machine learning, actually we talk more about mathematics actually. So it's become the bottleneck to understand. But in your opinion, if we implement or use the machine learning, is it important to fully understand about the theoretical background that related to the method? For example, if we use neural network, if you just use the neural network, actually we just open the Python and type the code and adjust the parameter. But sometimes we do not understand how the neural network works. So in your opinion, is it important for the machine learning user? I said use machine learning user because sometimes they do not understand the mathematical background. So is it important in your opinion?
Okay, good question. In my opinion, if you are a machine learning user, you just want to use the machine learning and develop some system or application, then you actually don't need much. You don't need much knowledge on the mathematical background of the model. You can just use the library and just call the model, just call the built-in function of the model, and just supply your data and train the model, and then deploy the model. But if you are a researcher, which you wish to come up with something new, or you want to enhance the existing model, then I think the mathematical background is very important. Yeah. Yeah.
I agree with you. Okay. Okay, maybe last question from me. So, what is your motivation to take a career in the deep learning in video analytics? What is your basic motivation?
Okay. Okay, thank you. So far, so far my motivation is I want to leverage the deep learning in computer vision tasks, so that I can help the society to solve their problem. That's why when you see what I presented, some of the problem come from the industry. So industry partner, they have the problem, and then we try to help them to solve the problem using the computer vision techniques. Then another focus is for my works. You can see that another of my focus is I try to use deep learning and computer vision to help some of the problem in the society. For example, the hand gesture recognition, we apply it to recognize the sign language, so that we can help the deaf people to communicate with normal people. Yeah, that is two main motivation that I explore in the deep learning and computer vision work.
Yeah. It's very nice. I hope your motivation can inspire other attendees.
I hope
okay.
so.
It's very nice discussion, and I got many inspiration regarding your topics. Even my topics is not too relate, but I also use neural network for another case. So this is the end of our session. Thank you very much for your presentation and your discussion. And we will close the session by photo session. So we have take
okay.
Okay, and host will take a shot. Okay, 3, 2, 1. Okay. Thank you very much, Dr. Lim.
Okay, thank you, Dr. Isman.
See you in other occasion. So I will give this session to Master of Ceremony to continue this program. See you.
See you.
Ladies and gentlemen, please kindly not to leave the forum, as we're going to have the closing ceremony of ICOICT 2020. and we will give you some important information regarding to the next ICOICT. Once again, please not to leave this forum as we are going to continue for the closing ceremony of ICOICT 2020. And we believe that you are waiting for the information regarding to the next ICOICT 2021. And we are still waiting for the participants from parallel session and also some of the committees to get involved and join to the closing ceremony. Thank you. Ladies and gentlemen, while waiting for the closing ceremony of ICOICT 2020 to be started, we would like to proudly present to you once again the video that is really interesting on the journey of ICOICT and also some of the videos on Yogyakarta.
The special region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family lived. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical tales. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. To reach Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendra Tari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Gambaran bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai berdampak.
Unfortunately, As a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
The Special Region of Yogyakarta is a provincial-level autonomous region which is the only officially recognized monarchy within the government of Indonesia. There are many famous places such as Malioboro, the major shopping street where a lot of goods is being sold, and Tugu Jogja, which is an important historical landmark in the city of Yogyakarta. The other exciting place is 0 Point Kilometer, one of the most favorite hangouts for young people. And then there is Keraton Yogyakarta, a place where the Sultan and his family live. Another iconic place is Taman Sari, the site of a former royal garden of the Sultanate. It is located about 2 kilometers south from the Keraton Yogyakarta. And of course, there is also a public research university and credited as one of the most prestigious university in Indonesia, Universitas Gadjah Mada. Yogyakarta is also famous for its natural beauty. There is exotic Gunung Merapi, the most active volcano in Indonesia. And then there's a magnificent beach named Parangtritis, which is laden with mystical things. Local folklore believe it is the place to meet the Queen of the South. They call her Nyai Roro Kidul. In Yogyakarta, there's a popular temple, Candi Prambanan, the largest Hindu temple site in Indonesia and the second largest in Southeast Asia. Far from Yogyakarta, in Magelang, there is also a temple called Borobudur, the largest Buddhist temple in the world. We reached Yogyakarta, the government has built a new international airport and it's already fully operated since April 2020. Besides iconic places and natural beauty, Yogyakarta also have traditional dance called Sendratari Ramayana, visualization of the epic Ramayana saga. This dance usually performed in many places, such as at Hindu temple Prambanan.
There are now more confirmed cases of the new coronavirus outside China than in the country, and the World Health Organization says the hotbed of new infections has shifted.
Europe has now become the epicenter of the pandemic.
Bahwa optimisme kita, COVID-19 ini bisa disembuhkan.
Informasi selanjutnya, wabah virus corona mulai berdampak.
Unfortunately, as a result of COVID-19 outbreaks, the Yogyakarta City Tourism Office currently closed several tourist destinations. Let's hope this pandemic is going to over soon.
Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves.
Good afternoon, ladies and gentlemen. We're going to start the closing ceremony of ICOICT 2020 in no minutes. But before, please make sure that you find your most comfortable positions so that you can have the best experience during the closing ceremony event. So we would like also to remind all of the participants, especially in the parallel session, to move to room A. And maybe at the same time, you also can remind your colleagues to join us here together in the closing ceremony, because we believe that every one of you are looking forward to knowing what is the next ICOICT 2021 to be. So we also would like to announce you many things on especially the next ICOICT once again. So ladies and gentlemen, we're going to start the closing ceremony of ICOICT 2020 in no minutes. Once again, we would like to invite and also remind each and every one of you to capture your moment while joining the ICOICT 2020 and then post the pictures to your social media like Instagram, Twitter, or maybe Facebook by using the hashtag of ICOICT or ICOICT 2020. So we will be very glad to see you all in your social media, and we believe that everyone in this world while looking for the keyword of ICOICT will see you as the celebrity there. So please make sure that you upload your picture to your social media. All right, so ladies and gentlemen, as we are waiting for the other participants to join and involve with us here in the closing ceremony and move to the room A, we are going to once again remind you and find your most comfortable positions, especially that we believe that you want to find your best experience joining the closing ceremony. All right, so once again, please remind your colleagues to get involved to the room A. Ladies and gentlemen, let's start the closing ceremony of ICOICT 2020. Honorable the representatives of Telkom University Indonesia, School of Computing Telkom University Indonesia, Faculty of Information Science and Technology Multimedia University Malaysia, and Faculty of Mathematics and Natural Science Universitas Gadjah Mada Indonesia. Distinguished keynote speakers, tutorial speakers, General Chair of ICOICT 2020, TPC Chair of ICOICT 2020, Chair of IEEE Indonesia Section, Chair of IEEE Signal Processing Society Chapter, deans, directors, lecturers, and of course, distinguished presenters and attendees from all over the world. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the closing ceremony of the 8th International Conference on Information and Communication Technology, ICOICT 2020, Thursday, 25th of June, 2020. I'm Yen Hamida. It is an honor to serve you as the master of ceremony for this closing event. Ladies and gentlemen, on behalf of the committee, we would like to congratulate each and every one of you for reaching this stage We believe that you have enjoyed the best moment, the best experience during the event from the beginning or from the first day until today. We hope that you can gain valuable knowledge and also experience, and of course, build stronger network with your colleagues and also with your partners during the event. So in the following minutes, we're going to have the chance to know the information regarding to the next ICOICT 2021, the words from the Dean of School of Computing, Telkom University Indonesia, and also outstanding virtual performance by Telkom University Choir. So ladies and gentlemen, without further ado, let's welcome Dean of School of Computing, Telkom University Indonesia, Dr. Abdurrahman Baizal, SSE MCom, to deliver a speech. Dr. Baizal, please proceed.
Assalamualaikum warahmatullahi wabarakatuh. Dear all participants of ICOICT and also committee members from Telkom University Bandung, Multimedia University Malaysia, and also Gajah Mada University Yogyakarta. For all participants of this conference, I'd like to thank for your participation, both as presenters and also as audience. And I also want to thank all the committee members who made this event successfully organized. The current ICOICT has the theme Leveraging ICT for Disaster Resilience and Sustainable Development. There are two special things about organizing this ICOICT. First, Telkom University is collaborating with our new partner, Gajah Mada University. Thank you very much. Besides our old partner, Multimedia University Malaysia. And second, because of this pandemic situation, ICOICT was held virtually. And of course, the committee must be able to learn quickly to adapt to this change. So my big appreciation to the committee who tried hard to adapt the implementation of ICOICT to the current situation. Of course, many obstacles experienced by committee to ensure the event was held well. I also thank Multimedia University and Gajah Mada University who have collaborated with Telkom University as the organizers of ICOICT. Hopefully, this collaboration will continue in the next ICOICT. Actually, we plan to organize this ICOICT in this year in Yogyakarta, and at the end, of course, at the end of the session of this conference, you could enjoy a city tour in Yogyakarta by seeing the beauty of Yogyakarta. However, don't worry, we will still hold ICOICT in Yogyakarta in the next year. Hopefully, this pandemic situation will end soon, so we can get back to doing many things normally. But it is possible that many future conferences will be held virtually as they are currently held, or they may be blended. But this is just my imagination. On behalf of the committee, we apologize for any shortcomings or some technical errors that occurred in the holding of this conference. Hopefully, this conference can provide benefits for us and also development of science. And see you next year in Yogyakarta. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Baizal, for a very inspiring speech. Ladies and gentlemen, the next agenda is the introduction to the next ICOICT 2021. On behalf of the committee, we would like to proudly present to you the next International Conference on Information and Communication Technology, ICOICT 2021, through a very interesting video. So ladies and gentlemen, let's enjoy the video of ICOICT 2021. Wow, isn't it so exciting to see and watch this sneak peek of our next ICOICT 2021? We're looking forward to seeing you again in person. And let's hope the pace for our Earth to be back to normal so that we can meet you, each other in person. And we can experience not only to meet each other with the other researchers, academicians, but also we can experience a very beautiful cultures originally from Yogyakarta. So ladies and gentlemen, distinguished guests, ladies and gentlemen, Telkom University Virtual Choir would like to proudly present to you a gift to bring home. So they will perform a very beautiful and harmonious performance on Re, Ayo Re. So let's enjoy their performance. Let's welcome Telkom University Choir.
Sopong ngerti nasib kenal anak esing rada cacingo
Let's give a warm applause for Telkom University Choir. So ladies and gentlemen, this performance marks the end of the 8th International Conference on Information and Communication Technology, ICOICT 2020. On behalf of the committee, I extend a warm gratitude to the representatives of Telkom University Indonesia, School of Computing Telkom University Indonesia, Faculty of Information, Science and Technology, Multimedia University Malaysia, and Faculty of Mathematics and Natural Science, Universitas Gadjah Mada, Indonesia. Let's create more collaborations and achievements, and of course, distinguished keynote speakers, tutorial speakers, General Chair of ICOICT 2020, TPC Chair of ICOICT 2020, Chair of IEEE Indonesia Section, Chair of IEEE Signal Processing Society Chapter, deans, directors, lecturers, and of course, distinguished presenters and attendees from all over the world for your time and attention and making this event a success. Before leaving this forum, on behalf of the committee, please allow me to announce you several information regarding to the conference. For those of you who come from Telkom University or Telkom University participants, you can gain your seminar kit by taking it directly in the campus. So you can contact the Secretariat of ICOICT directly. And for those of you who come from non-Telkom University or non-Telkom University participants, we will send the seminar kit to your home address based on the address that you attach or you send to the committee. And on the process, the committee is undergoing sending or distributing the forms on regarding your address. So please kindly fill in the form as good as possible and as responsible as possible. And also we will send the seminar kit to your home address based on that form. So ladies and gentlemen, last but not least, we're looking forward to seeing you again in the next ICOICT 2021. And on behalf of the committee, we would like to say see you soon and see you again next year in Yogyakarta for the next ICOICT 2021. So I do apologize as the master of ceremony. Great to meet you all and stay safe and of course happy. Good evening, ladies and gentlemen. Wassalamualaikum warahmatullahi wabarakatuh.
Oh, jadi pilih. Gimana?
Ini yang bagian penjelasannya di sini juga nggak boleh satu paragraf gitu.
Nah, kalau ini kan bukan subbab kan? Subbab nggak masalah. Terus ke bawah. Ya, saya hujan terus.
Dapat masuk kesimpulan. Kesimpulannya saya jadi penasaran.
Nggak apa-apa. Coba baca dulu kesimpulannya. Coba baca dulu kesimpulannya.